Hi.
Hello. Yep, we can hear you. Hi. Yep, we can hear you. So, should we share our screen then?
So let's go.
Uh,
Let's start.
Can you hear me?
yeah, yeah. Can you hear? You can hear me, right?
Hello.
Hi.
Arpita, you can hear me fine, right?
Wait, right, I can hear you.
Yeah, yeah. I thought it's something on my end.
No,
Okay, okay.
Hi. Rohit. Hi, Peter.
Yep. Can you hear us?
Yes. Now I'm able to hear.
Awesome.
Um, are you ready with the presentation?
Yep.
yes.
I can start sharing the screen for the deck that we
Okay.
have.
Sure.
Just
Hello. Welcome everyone to the Azure AI Connect 2025. This week, from March 10th to 14th, we are exploring how to shape the future of AI. Today is day 5. The last day in the series. Our topic for the session is innovation with Azure AI from LLMs to cognitive services, featuring Rohit Yadav and Arpita Das. Thank you for being here. Now it's my pleasure to hand over the stage to our esteemed speakers. The stage is yours.
yep. Just give me a moment. I'm sharing my slide deck.
Sure.
Yeah. Naveen, just one request. Can you add my screen in the show?
Sure. Yeah, I think it now. I think it should be visible now.
Yep.
Yes.
Awesome. Awesome. Over to you, Arpita.
Okay. Hi, everyone. Thanks for joining us today. And to everyone joining from India, happy Holi to you all. So, today we're here to get a beginner and an intermediate level of deep dive into how we can use Azure and Azure AI LLMs, cognitive services, and custom vision to build, projects which can actually be a remarkable demo. So, moving ahead.
Yep.
Yes, a bit about us. I'm Arvita. I'm a software engineer at Myntra, and currently I'm an MVP for Azure AI Cognitive Search only. So yes, my session will be based around that by a lot. And before that, I was also a Gold MLSA and intern at Microsoft. So yeah, and I'm from Delhi, India. Rohit.
Yep. Thanks, Arpita. So, a brief of my intro. I guess all the things that are same except for one change that yes, I'm working as a Microsoft consultant where I do lots and lots of development over the Microsoft stack, like Azure, SharePoint, Power Platform, and so on. Um, and yeah, it's a esteemed pleasure to be here and to be guiding you around Microsoft AI. So we are talking about a couple of topics today, which should be of help to you. And the topics that we are covering today, they cater to a wide variety of audience, whether you are like a seasoned um, AI professional or you're someone who is totally new to this field, there is something in store for you here. Yep. So with that in mind, I think I'll hand it over to you, Arpita, because the next part is yours.
Sure. Okay, let's go. Okay, so Microsoft Azure, we've already mentioned it a couple of times, but what is it? So it's a cloud service provided by Microsoft, and there are a couple more services. You have GCP, you have AWS, but we are streamlined around Azure. Now, what is cloud? So you know how when you start building a product or a service, you start managing multiple things like the network connections, the accesses, the data centers, everything. So what a cloud does is it acts as a helping hand to you when you're planning on that. So let's say like you would have heard about these software as a service, platform as a service, and all these kind of domains, right? So what a cloud will do for you is, in general, it will take care of the resources while you can focus on building the development and whatever service you're up to. So similarly, the Microsoft Azure one, it supports a lot of third-party softwares, a lot of languages, a lot of models. Like today we'll go with custom vision, but I'll also show you the other models and the other resource groups that it will support. And the best part is like you can code in any language you like. And you can also streamline it to your low code softwares like your Power Platform, Power BI, and all those apps. So basically, what Microsoft Azure does is it acts as a platform for you to channel your developmental goals via different other resources. And the best part is like it has a large scale virtualization. So global data centers around the world, it actually becomes very stable like that. Moving ahead. Yeah. So Azure AI. So okay. Like I understand these are two lines of definition, but I hope that as we move ahead in the demo, you'll understand more about why we are emphasizing on Azure AI. And it's not just about prompt engineering or having a model to work. It's about how you can integrate those things to build something that can actually work on its own. You want to add anything here, Rohit?
Nope. I think I've already covered. So I think as we move forward with these slides, you will actually realize that Azure AI is like a very comprehensive platform because it incorporates everything. You have like ready to consume models right inside your apps. Then you have a middleware platform where you can bring in your code and let Azure take care of your model. And then you have virtual machines with support for the best in class NVIDIA GPUs that enable you to like handle all the stack together as you may like. So we have everything in here, and I think, yep, that's all from me. So I think let's move forward with the
Yeah,
slides. So yeah, the first part here for the first topic for today is custom vision service, and I think I'll hand it over to Arpita over here.
sure, thanks. So, custom vision. Now, what it is let's take it as an image recognition model. Let's say you build a model which you train with a lot of images, and then you throw a random graphic at it, and it's able to predict what the graphic is. How you can make it work, you can have it in multiple things. Let's say, like, if you remember when there was the COVID pandemic, they were assessing people via cameras, like who was wearing a mask and who was not. So when you scale these small models to larger levels, they'll actually help you emphasizing and reducing the time it would have taken a man to come up with those solutions. So I'll give you a very small demo on how it can be done. Can we see the next slide, Rohit? Yes, okay. Now, before we move ahead with what is custom vision, I want you to understand that there are ways in which you can divide your data. So let me give you small definitions and examples. So first one, as you can see, classification. So what happens here is, let's say you take a collection of images and you have to determine what the image is. Okay, so let's say you train a model using labeled images of, let's say, cats, dogs, and all. Now what it does is the model, it learns to distinguish between the two classes. So whenever you will provide it an image, it will be able to tell you whether it's a cat or dog. That is the easiest way. Next, we have reinforcement learning. So, if you guys go to a gaming arcade, or if you would have seen how the self-driving cars came up, you would have seen that these self-driving cars, they were simulated to navigate through a city by themselves. So how it works is they get a visual input from the environment. So the environment in this case is your simulation. From that environment, it takes the actions whether to turn, whether to accelerate, or the penalties and all. And over the times, by giving them a different kind of environment, the self-driving car, it learns how to navigate around a place. So the third one next is regression. Okay. So, okay, I know a lot of people are into trading and stock market and all. So, regression, well, a perfect example could have been estimating house prices from the images. So, what you can do in this case is you can train a model using images of houses with their corresponding prices. In that case, the model, it learns to establish a relationship between the visual features and the price. So let's say I give the model a normal hut, and I say like, okay, it's 10 USD maybe, and then I give them a very good bungalow and it's like 1000 USD. So once you start training the model like that, it gets a general idea of how much a house should be in a particular time. Then the next one is anomaly detection. Like the name suggests, you're trying to pick out a defective product from the production line. So let's say you okay let's say you put a lot of normal products into a model. Okay, I put a lot of normal apples in the model, and then suddenly I give the model a picture or an input of an apple bitten by a worm. So it will immediately throw that out, like this is not the correct thing that we are trained on. And the last one is clustering. So again, like the name suggests, what you're doing is you're grouping data set into certain categories. Let's say you organize a collection of flower images and then you group them based on the visual similarity. So I put all the roses together, all the tulips together, and then I give them a random image of yellow, black rose. So it knows it's a rose, right? So you've already clustered it. So this was an overview on what 5 types of learning techniques are there. Rohit, in case you want to add anything, you can.
No, I think that would be pretty much it. You have already covered basics very well.
Great. So moving ahead. Yes, correct. Now it doesn't happen that you randomly throw an image and the machine already knows what needs to be done and what to do. So everything is indeed enabled by machine learning, and there is a data set here. Moving ahead. So there's a good diagram that will help you understand. Yes. So I hate to break this, but math is very important. In case you don't like math, you'll need it very much indeed. The whole concept of AI relies pretty much on computer science, well, and math, because whenever you're training a model, you need to know how efficient it is, whether it sits right with the formulas of calculation or not. So all of these things, ML, neural networks, everything is a subset of AI, and all of these interact with statistics because your prediction model has a prediction word which comes from the statistical formulae. Okay, moving ahead. Yes. Now, our current project, so I have taken a very easy category classification so that it's easy for everyone to follow up. And in case you want to build it simultaneously, you may do that. Otherwise, you can ping up with your questions as well. So, moving ahead. Hmm. Now, it's a very simple 3-step process. And like we have it in the deck also. Rohit, you can bring the others up as well. Yes. So, like I said, how classification works is you add images, you add certain labels to those, you make sure the model is trained on that, and then you evaluate the results. So, these 3 simple steps are only there, and now I'll tell you how it needs to be done as well. Okay, the demo, yes. So, I will present my screen. Let me know once it's up. Can you guys see my screen?
Just a second, it's coming to. Yes, we can. Yeah.
You can? Awesome, great. So this is your Azure portal. Anything you want to build on Azure or integrate with Azure, you have to come to the portal, portal.azure. Now, for any kind of project, let's say in this case we have a custom vision model, you need a resource group because you need to specify the certain resources, the tiers, the regions from which your particular project should be linked to. The first thing that we do is we create a resource group. And see, now, like I told you, there are multiple services that Azure has to offer. You can have a SQL database linking, you can have a logic app, you can even integrate it to GCP if you want to. But in our case, we have custom vision. So first thing I'll do is I'll go here and search for custom vision. Okay, it's taking some time. Let's try it again. Hmm. Yes, okay, great. So I searched for custom, and now you can see there's so many things with that name. So you can explore these as well. But let's go to custom vision. So you can see here what they're doing is they're giving you an Azure AI service, and you can build an end-to-end platform for CVs, custom visions. So what I do is I go to create and then create custom vision. We'll give it a couple seconds. Great. Now, see, you can build whatever model you want, but I will build a model where we will train the model and then we will assess the prediction rate. So I'll keep the create options as both. Subscription could be anything that you are eligible for, and post that there's a resource group area. So you can either create a new resource group, or if there is some existing resource group to which you want to link it, you might do that as well. So I'm going to link it to the one I already made. Then region. It's normally recommended that you choose a region that's near to you, and you can give it any good name. So let's say I make it CVAI. Okay. Some random gibberish then. Okay. Don't do random gibberish. Think about a good name. I have already made a model, so I'm going ahead with this. Then there's a pricing tier. You can go with a free tier, and after you've filled all the details, click on review plus create. Now, I've already created my resource group, so let me take you there. Yes. This is my model group. And now this is the, okay, this is the resource group we have for training. So you remember we did prediction and training. So this is the one for training. We can see it's active and it's in Central India. And similarly, there is a prediction one as well. Wow, it's really slow today. Yes, there's a prediction one as well, and which is also active. So whenever you're trying to link anything to your resource group, make sure it's in active state. If it's dormant, you will face a lot of problems establishing the links. So this is the first step which we have done. Okay, we have the resource group ready. Now the second step is going to Custom Vision's website. So you can simply search for customvision.ai. It will lead you to this website. Now this is a project I've already created, but if you want to create a new one, you can go to the new project. And it's very easy. You give your project a name. Let's say I want to call it Animal CV. CV being custom vision. You can add any description. I'll say CV for animals. Now your resource here is the group you just created. So make sure you map it to the correct resource group. Now, okay, so there are types to project and we'll go with classification. I've already selected that. Now classification also has types. So okay, I'll tell this also. So for now we'll go with a single tag per image. So if it's a dog, it's a dog. If it's a cat, it's a cat. Further, if you want multi-label, it could be multiple tags per image. Let's say dog husky, dog golden retriever, like that. And domains are majorly just categories you can put your images into. They can be foods, landmarks, but since we have animals, I've just put it as general. Once you've added all the data, click on create project. So I've already created it. Let me take you there. Correct. Yes. So this is the model that we have here. Now I'll tell you how we created it. The first thing you have to do is you have to go to add images and then select for whatever image you want to add. Let's say I want to add this dog. I'll give it a tag of dog. It's a predefined tag that was already created again. Then I'll upload it. So okay, now we can see one image uploaded successfully. It already put it here in dog and now we have it here. But now if I try to upload a similar image again with the same tags, what happens? The image will duplicate. So it will also help you maintain a better data set because you will not have duplicate images. Now let me explain this tagging part to you. You know how we shop on the e-commerce websites like Amazon and other websites, and when you have to select a particular category or a particular color, you just go and click it or click on the filter for that. It's the same thing. The tags are your filters for the animals in this model. If I, let's say, click on zebra, we'll have only the zebra images available. Now you might also notice one thing, that there are multiple shots of the zebra. Like there's a front shot, there's a side shot, there's a back shot. Now this is recommended when you're training your model, because if I were to throw a random snippet of an image, the model should be clever enough to know, okay, this is the animal we are referring to. So whenever you're training a model, make sure you have a good data set and pictures from a lot of angles basically. Okay, so till here we were on the part where we were training the model. Now, once the model has been trained, once you've added your pictures, you click on train and then you choose for quick training or advanced training. Normally, it might take 20 to 30 minutes. So this is a pre-trained model that I'm showing here. Once the model has been trained, you go on quick test because we need to see if it works or not, right? Now, after that, you can upload a file from your local system and see. The model said that it's 99.9% sure it's an elephant, which means we have trained it well enough to decipher from a random snippet if the animal is correct or not. But if I were to give it some other thing, like let's say I give it this butterfly, see now it 95% thinks it's a zebra, because when we were training the model, we did not give it any image of a butterfly. But if you were to observe, it has white and black stripes, kind of similar, matching to a zebra. So the model thought this is a zebra. So make sure that whenever you're training a model, you add a good amount of data set. Try to cover as many related topics you can on that from as many side angles you can. Okay. So, ठीक है. So after this, okay, there also comes an aspect of performance. So whenever you're building a model, post that you need to know like if it's performing well or not. Now, since we have a very small data set, I mean, it's not even 100. Everything is 100 for us. But when your model starts growing, let's say you take it to crores and lakhs and those kind of data set, then you'll see the numbers dropping a bit, which again is fine. So let me explain these terms to you, precision recall and AP. So the precision part, this actually measures how many positive detections were actually correct, right? So let's say if the model was detecting dogs in images and it predicts like there are 10 dogs but only 8 of them were dogs, then it would be zero point 0.8 or 80%. But in our case, it was able to predict all of them. Similarly, now recall, it measures how many actual positives were correctly identified. So if there were 12 dogs in an image, but the model detects only 8, then it would fall up to around, I think, 67%. But again, since our data set is very small, the model is accurately working on it. And there's one AP section. AP stands for average precision. So what it does is it summarizes the precision recall curve, which means it will tell you how well the model balances the precision and recall across different thresholds. I hope everything is clear until now.
Yep, all good.
I'm good because I will take that for a yes. So that was the part of the demo side that we had, and now I think we can go back to the deck. You can
Yep,
start sharing a screen, Rohit.
just give me 1 second. Yep.
Yeah, moving ahead.
My screen is visible, right?
Right.
Cool. So I think that finishes off with custom vision. Before we proceed ahead, I think we can stop once again if there are any questions, anything related to demo that Arpita gave. It was a really awesome demo, by the way.
Fine.
We had like a total end-to-end work of the service, and anyone who has been able to follow along, you will actually realize it's a very easy to use service.
Yes.
So I guess we don't have any questions for now. So we can move over to the second service that we have. Um, so let me go back to my slide. Yeah. So this section will walk you around Azure OpenAI Service and AI Search. So again, you might have heard of OpenAI already. Like it's not a new term anymore. It has been sticking around for years, making years. I think months would be more appropriate. Like for the past couple of months, making waves and waves every time with their new models, Chat GPT, and so many products. So yeah. Um, but yeah, why OpenAI here? So we'll come to that shortly. But I'll walk you through the Azure AI catalog. So remember where I talked about the three types of tool chains that Azure provides us. The first one is ready to consume models, which are built by Microsoft itself. So and other partner models as well. So if you see, we have a couple of models here, and all of them serve different purposes. So let's say if you want to do some analysis around document intelligence is your buddy there. If you want to do anything like, let's say, maybe related to indexing, indexer is your go-to tool. If you want to let's say use any speech related tools, like maybe you want to translate text, you want to um, do stuff like that, so language is your go-to use case. If you want to work around text to speech or speech to text, then speech will be your buddy. And for like the use case that Arpita showed you, where we need to deal with images, Vision is our go-to choice. But if you see, we have a new service here, which is Azure OpenAI service. So in case you are not familiar, Microsoft and OpenAI, they are very close partners. So um, you can read more about their partnership. But as a result of that partnership, we have the OpenAI catalog of models. All of them are available on Azure and only on Azure. So which makes Azure number of much more preferential use case if you are someone who is looking forward to learn Gen AI, or you are a professional developer and you want to utilize OpenAI APIs inside of your application. But you might at the same time ask, like, you can access these models through OpenAI itself. Like, why do you actually want to go through Azure? So we have a couple of reasons for that, and we will be exploring that. And besides that, I'm not sure if you can see this, but Microsoft also has a ML platforms offering where you can bring in your code and then train it on the cloud without using your local compute. And then you can provision an entire AI infrastructure, which will uh, give you the entire control over the stack. So when we talk around Azure OpenAI Service, we have some top capabilities like content generation. Again, one of the main services that you might want to use. Then we have summarization, we have code generation. So you might already be using GitHub Copilot if you are a developer. So you might already be familiar with that. And then we have semantic search, which is powering a whole new field today called as agents, um, that are powered by these LLMs. So that are like some top use cases of Azure OpenAI service. Now, again, you might know all of these services that are powered by OpenAI, which is GPT. Again, they are multimodal LLMs, family of LLMs. Then we have Codex, which is the model that is used for programming related tasks, and it powers GitHub Copilot today. um, DALI is used for image generation. So anytime you ask ChatGPT to generate an image, or you go to DALI and you submit a prompt there, it goes to DALI, then ChatGPT again. Everyone here has used ChatGPT, so no introduction needed for that. But now, if I talk about why you might prefer wanting to use Azure and use OpenAI service from Azure instead of going through OpenAI. So there are a couple of benefits there. The first one being that the service is deployed within your Azure subscription. So if you have an Azure subscription already, it will be available there as another service. And you might not realize this right now, but if we have any professionals in the room, you might realize that generally enterprise and organizations, they prefer having bundled services together, because it means lesser IT overhead, lesser management overhead, and it's much more easier to manage. So that gives you one preference there. Then you have large pre-trained AI models to unlock new scenarios. So you get lots of models there that you can fine tune and use as per your use cases. um, you can again fine tune these models with your own data, with your own hyperparameters. So you can very well customize it to your own scenarios. um, One key advantage here is that it has built-in responsible AI. So Microsoft actually focuses a lot on responsible AI, which ensures that these models are safe to use in your production environments. It does not hallucinate, or it does not ends up giving any bit of information that it's not supposed to. So we have very powerful controls for that. If we get time in this session, I'll be giving you a quick walkthrough around that. And last but not the least, we have enterprise grade security with RBAC controls, private networks, and all of that, which makes it a key choice if you're someone who is in enterprise. At the same time, I think I'll stop if we have any questions right now. Any questions coming in, Arpita? Do you know?
I don't see anything yet.
Okay. So I'll take it as a heads up that everyone is understanding the slides very well. So we'll proceed ahead. Um, the next service here is cognitive search. So this service has been rebranded as AI search, and it powers vector searching capabilities. So what does that mean? So um, your different types of data like images, video, graphics, documents, text, all of it is converted into vector, and it is stored in form of a vector database in this service, which is called as AI search. So what happens there is you can bring in your own embeddings, you can use OpenAI's embeddings, and it's all integrated within Azure. So what happens there is the service ends up powering your own data, and then you give it to these OpenAI LLMs, whichever ones you pick, and then you can get a very personalized answer, which is what we are looking at. So again, both of these services, when they come together, they really power some beautiful experiences, and some of this you can already experience if you are using like any of these new services that exist together that are powered by LLMs. You are already using either of these combinations. So moving ahead, now I'll show you a very quick process flow diagram. I'll not spend a lot of time here, but this is how these two services work together in harmony. So let's consider this app UX as your starting point, and through this, if a request is triggered, so it goes through Azure through its app server or orchestrator, and then it sends it across to both AI Search as well as Azure OpenAI. So these two services, they talk together. If it's a personalized answer, so OpenAI service sends it across to AI search, which fetches the information from whatever data sources it has access to, and then it goes back to OpenAI, and your response goes back as a personalized answer. So I hope that was clear, and I think we'll now proceed with a quick demo of Azure OpenAI service and AI search in action. So I will share my screen again. Um, just give me one quick second. Yeah, awesome. Um, can you see my screen?
Yes.
Awesome. So now we are going to take a quick look at Azure OpenAI service, and for that we are in OpenAI Azure OpenAI Studio, which is a part of what we call as Azure AI Foundry. So this entire stack has been rebranded very recently, and it is now called as Azure AI Foundry, which is a collective term to refer to all of the tools that we have discussed right now. So Azure AI Foundry, it powers all of these experiences that we have taken a look at, uh, including custom vision that was shown by Arpita, and now Azure OpenAI service that I am showing you here. So I'll give you a quick walkthrough around the portal, so that, and we'll keep it very easy so that it does not goes over the head, because it can become very tricky at times. So um, when you go into service, you provision an instance to Azure portal, and once you do that, we are in Azure AI Foundry, and we have access to all of the models that are available here. So now you can utilize a lot of models here, and these models will look familiar to you if you are already utilizing ChatGPT, because a lot of these models are available over there. And it also has even new models that are um, being launched by OpenAI. For example, we have GPT 4.5 preview, which was just launched very recently, very recently. And then we have all of the models going from O3 mini, O3. We have again all of these models that are integrated with audio access, so you can chat with them as well while submitting different prompts to these models as messages. And it goes all right back to GPT 3.5 Turbo, which was the base model that ChatGPT shipped with. And it's still in use. If you use ChatGPT, you might still, there are chances you might be using ChatGPT 3.5. So the first step is to pick a model. The second step is we go into playground, which is an area to basically test how you want the model to perform. So there are a couple of properties here that you might want to take a look at. So the very first property there is around picking a model. So I have deployed a couple of models already. So I have a GPT-4o model that is deployed. Then I have a GPT-4 model, and last but not the least, I have a GPT 3.5 Turbo model. So for this demo, I'll pick GPT-4o, and then we have something called as system message. So the system message or system prompt is one of the most important elements. So this area is whatever you write here, basically you are telling that to the model that you are this person and you have to act like that. So whatever we write here, the model will answer accordingly. So we have uh, for the timing, we have written that you are an AI assistant that helps people find information. So the model understands that yes, my role is to act as an AI assistant and to help find information and give it to the user. If you want to behave it in a different way, you might want to switch it accordingly. So for the time being, I will ask it a very simple question like, what um, is your purpose? A very simple one, and we might expect an answer. So yeah, um, again, it talks very much around the lines of AI assistant. If you check this line, like knowledgeable guide who can help you navigate topics, learn new things, and so on. Um, Now, but you have full autonomy to play with this area. So I might insert a line around responses, like how I can expect the responses. So I'll make a quick change to this area saying that make use of ample emojis across your responses and maintain a cheerful tone. So what happens now, I'm altering the system message and I'm telling the model to use a lot of emojis in its answers. So at least you might start seeing some emojis now. So I'll just start with a message as simple as hello, and you might expect some emojis. So yeah, we have three emojis in there already, and it might give you a cheerful tone as well. So let's say I ask it a simple question like, can you help me with this one question, please? So yeah, see, we get that cheerful tone here, like I am all ears, well, virtual ones, and then you have all of those emojis. So just like that, your system message actually manipulates the models because it tells the model that you have to behave like that, you have to answer in this way, you have to behave this way. So you can set all of the restrictions there. And similarly, like I am setting the behavior, I might also impose some restrictions saying that if you get asked any questions around this topic, you have to resist answering, you have to not answer that, and so on. So that's how um, system message performs. Similarly, you might alter some other bits of information here. You might alter some other parameters that are included, like how many past messages do you want to be included in the chat, what should be the maximum number of tokens that should be used in your responses. Then temperature, this is one of the key properties. Basically temperature says your model whether it has to be more precise in answering it had, or it can just um, be more creative, as in like it can think and provide an answer as per its training data, and so on. So after we have configured our models with these properties, we get ready to publish our model. And how we publish our model, we publish it as a web service. So if you click it to deploy as a web app, so this model will be deployed as a web service, and you will get some API endpoints that you can utilize in your own apps. So you might want to just set it up like that. Similarly, you can also export it in different formats. Microsoft has some prompt samples as well that you can use there, and so on. Um, there are some other fields as well, like assistants and all of these. So let's say if you are interested in building agents, you might want to utilize assistants field. So I'm not talking about agents for now, otherwise it will get bit difficult. And similarly, let's say if you want to utilize other solutions, like maybe you want to build an image generation app, so you might want to utilize DALI APIs and so on. You can set all of that different fine tuning experiences from here. And then let's say if I go back to one of the key services that I wanted to show, it's around safety and security. So this is around the responsible AI service that I was talking about. So I can create a content filter, and I can enable it to filter these types of content that you can see, like violence related content, hate, self harm, and so on, like jailbreaking, so that the model cannot give out answers which it isn't supposed to. So this was a very quick walkthrough at Azure OpenAI service in action. Again, there are lots of use cases that you might want to think around and utilize in your own applications as you work with the service. But yeah, that's a very quick walkthrough, and I hope you could understand how we work with this service. With that, I will go back to my slides. I'll share my screen again. Let me know, Arpita, if you can see my screen.
It's coming up. Yes, it's visible.
Awesome. So with that, we have completed our demo part, and that's it. We are at an end of this session. So thank you so much for sticking along. I hope you have been able to understand these two services that we have tried to walk you past today. And yeah, any closing remarks, Arpita? Anything from your end?
Yeah, just
Thank,
one note that whenever you're making an AI model, make sure you train it with ample amount of data set to have a perfect, not perfect, but next to perfect model. That's
thank
all.
you so
Yep,
much, Rohit
absolutely.
and
So we will
Arpita.
pause for a minute here if we have any questions coming in. Otherwise, I think we can maybe call it a day, and we might try to answer your questions if you connect through LinkedIn or you shoot it at us our other social platforms.
Thank you, Rohit and
So, any
Arpita.
questions, anything
Are you
for
able to
us,
hear me?
any feedback or anything else?
Are you
You're
able to
audible?
hear me?
Yes.
Yes, yes,
Yes.
that's.
Thank you, Rohit. Thank you, Arpita, for your presentation and demo. We are so grateful that we had you with us, and hopefully we will see you in another event of ours. I cannot see any questions. I don't know if anyone has any question from for Rohit or Arpita. We definitely going to see your demo again. Remember, our stream is also recorded, and you can find everything in AI -athens.gr, where you can find the recorded streams as well. Let's say goodbye to Rohit and Arpita for now. Thank you so much again. We will stay connected. Have a great
Thank
one.
you. Thank you
Thank
for
you so
having
much.
us here.
Bye
Thank
bye.
Bye.
you. Bye bye.
Great. Um, Next is our very well known to our channel and across the communities of Microsoft all around the world, I will say. We have Javier Villegas with us. Um, Fabric is the main point, but it's not only Fabric. It's an introduction to Fabric data analytics for the era of AI, one of the most interesting topics of the last year, I can say. and I am confident that most of us working in the enterprise world know that this is a hot theme. So I will take a 5-minute break before Javier will be introduced to the stage. Stay connected, Azure AI Connect 2025. Javier Villegas in 5 minutes with us. Thank you, everyone. I'm just gonna play a video for the next 5 minutes or so. Thank you. Hello again. Hold on, please. Javier is with us. Javier Villegas, um, an IT professional, Microsoft MVP. Uh, I have no words to describe the expertise of Javier. We have been connected in the past in another event, more than once, if I remember correctly. Let me bring Javier on the stage. Hello, my friend.
Hi,
How
Constantino.
how are
How
you?
are you? How are you doing?
I'm great, thank you.
Nice to see
Thank you
you.
for joining, Javier. You are a great supporter of our group, and we're so honored to have you with us, presenting your expertise and your know-how. Quite an interesting topic you have selected. And to tell you the truth, as an solutions architect, I'm dealing almost every day with this topic, fabric, and how we can integrate AI into our fabric. So I guess you have to say a lot of interesting topics about this theme, and
Yeah, no,
I would
absolutely. This a quite hot topic, right? Data and AI, right? You will see. I will, you know, highlight one of the slides that I will present. Data is the fuel that powers AI,
yes,
right?
yes, 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 exactly.
Uh,
Okay, I have someone with us. I bet you know.
mhm. Hello, hello.
Romana.
Hello, Javier. How are
Hey, how
you?
are you? How are you doing? Nice to talk to
I'm
you.
doing good.
Great, great, great. All right.
Great.
So
You can
you
share
tell
your
me when we're
screen.
ready to move on.
Yes, you can share your screen, Javier. I will add it to the stage, and you are good to
Okay.
go.
1 second. Screen. Oh, let me share again because I didn't put the audio here. Share system audio here. Uh,
Perfect.
good, good. You see the screen?
Yes, we can see your screen. You're on the driver's seat.
Okay, so ready to roll them. So give me 1 second to prepare. Right. All right. Uh, Thank you, Constantino, and the whole community. Definitely, it's a pleasure to me to be here today. It's not my first time with this community, which I love. I Everything when it's possible to talk about data and now data merged with AI. I will try to be there, right, as an attendee, as a speaker. I'm a data person, and definitely these kind of events are great for the community, right? For all of us to connect, learn, and share. So thank you again for allowing me to present today at the Azure AI Connect 2025. Mm. It's a wonderful event, and I know that you've been through some great sessions already. So let's move on with this one. Mm. Name of my session is Introduction to Microsoft Fabric, right? Basically, is a brand new data analytics platform, right? And the subtitle of this presentation is actually what it brought us all here. Data analytics for the era of AI, right? This is something that definitely is changing the industry nowadays. Data analytics, and of course AI. We see all the push, not only from Microsoft, from all the vendors in the AI space. So the idea today is just walk through the solution Microsoft Fabric and see how AI will fit within this solution. Mm. A little bit about myself. My name is Javier Villegas. I am from Argentina. I work at Mediterranean Shipping Company since around 19 years. I've been involved with the Microsoft data platform since 30 years. SQL Server, Azure SQL, and now Microsoft Fabric. Right? I'm MVP in the Data Platform Award category. I'm also Microsoft certified trainer. Right? I define myself as a technical speaker. As I mentioned earlier, I love to be there when we're talking about data. Right? I had the opportunity to present big events like Build and Ignite, as well as on the past Data Community Summit. Right? I'm one of the organizers of our local community here, SQL Argentina. We speak in Spanish, right? But if you feel comfortable with Spanish, definitely we have our monthly events in where we share some time all together and we have some fun. Right? You also have my contact information, email address, X handle, and LinkedIn, as well as my blog. In case you would like to get in touch with me, if you have any questions related to this presentation, or you just want to get in touch with me, please feel to reach me out. It's going to be a pleasure to network with all of you. Mm. So let's move on. Mm. Microsoft Fabric, a unified analytics solution for the era of AI. I will be reading some phrases during my presentation, which has some sort of key words, right, that we will be analyzing all together. There's going to be words that will be popping up here, and we're going to spend some time trying to discuss what they means, what data analytics and AI can merge all together, right? And then at the end of the presentation, we're going to see a brief demo on what are the things that we are able to do with Microsoft Fabric, right? First of all, Microsoft Fabric has been announced a little bit more than a year ago during the Microsoft Ignite conference in Seattle back in November 2023. So it's in the market 1 year and few months. It was presented as general availability, meaning that it's ready for all of us to use in production environments. So if there is any support request, any problem, right, you can open the support request because it's general availability. Mm. So also, and the solution was presented by Satya, but also was on stage Arun, the CPV of the whole Azure data stack, right? And he also highlight this phrase that I love and I always take in on my presentations, right? Data is the fuel that powers AI, right? I couldn't agree more, right? We're gonna be building analytical solutions, right? That will feed up, right? The machine learning models, the AI models that will be also available for the whole AI community. So for us, like data specialists, right, data professionals, we are definitely working on the back end, on the background, on the AI infrastructure. Mm. So some of the key elements on Fabric, right? But also we have this interesting phrase at the top. Microsoft Fabric is an end-to-end analytic platform that provides a single integrated environment for data professionals and the business to collaborate on data projects. Right? Here, there are a bunch of things that we can analyze. First of all, end-to-end analytic platform. Right? End-to-end means that you can do everything that is related to your data project. You can ingest the data from the sources, right? Store the data, process the data, then we will see how and which are the caveats that we have over there, right? And we can also generate the requirement that we have in terms of data analytics, engineering, warehousing, data science, the real-time analytics, and at the same time, Power BI, right? Power BI is also a component that is part of Fabric that will, of course, help us to visualize, right, the result of our project. So that is what ends-to-ends means. So we don't need anything else, right? Everything we need is included within the Microsoft Fabric solution, right? And provide a single integrated environment for data professionals, right? That means that if we are working on a data engineering process, we're going to require some skills, we're going to need some components, right? If we're going to do a data warehouse, we're going to need completely different skills and objects to work with, right? Uh, but within Fabric, the interface will be adjusting to our needs, right? Depending on what we need to do, right? The interface will handle everything for us. Again, once we get into the Fabric portal, we don't need to leave it, right? We have everything we need on it in order to work, right? So that is what integrated environment for data professional means. And then business, to collaborate on data projects. This is huge because, historically, all the analytic solutions were based on data duplication. Let's say we're working on the same company. We have a data set that we are working with for any specific project. And let's say that another area of our company needs that data set for them to, do a different thing with that, right? Historically, right, we just grab this and we copy and they deal with that, right? So the data duplication is always a problem. Why? Storage first, and then when you have two different copies, right, you don't have a single source of truth, right? So that is what the problem starts, right? So within Microsoft Fabric, and we will see how, right, we have a storage layer, right, that we will emphasize later on, right, that will help us to work ourselves, and eventually, if we need to share for other projects, we can easily, right, provide some component for them to use it without any data duplication, right? As I said, historically, right, we used to do the data duplication. Now we're trying to avoid it as much as possible, right? It is also quite interesting because this is an end-to-end analytic platform, right? And is something that is not mentioned here in the slide, is a SaaS solution, right? Software as a service. That means that, as I mentioned earlier, we need everything. We have everything that we need within the portal, right? And we don't need anything. We don't need to just, provision virtual machines or buy hardware and download software to install, configure the networking, do the whole wiring for the authentication, and so on and so forth to, start our proof of concept, right? This is how we used to work, right? Dimension the whole environment, uh, prepare it, etc. That's going to take several weeks, right? Now, with this software as a service solution, we may need just few minutes to set up our POC, and in a matter of no more than a day, we're going to have our conclusion, right? And we will see later on that without spending any money, right? That's quite interesting as well. Mm. It's also important to highlight that before Microsoft Fabric, right, Microsoft has some product and services targeted to data analytics, right, in the Azure platform, right? Data Factory for ingestion, right? Azure Synapse Analytics to store and process the data, and Power BI. Three different components, right? So if we need, if in the past we had to build an analytic platform, we had to, first of all, buy the three components, right? The licensing, each of them have its own licensing model, right? Then do the whole networking, right, between the three of them, just for, data access, et cetera, authentication, etc. And then we were able to do our project, right? Now within Fabric we have everything under the same scope, right? So when we get Fabric, we get the ingestion part, we get the store and processing part, as well as Power BI, right? So nothing else is needed, right? And this is also quite important because it's clear for the billing, right? So we are just paying for a Microsoft Fabric capacity, right? And before we had to pay for the execution of the pipeline, the dedicated pool or the serverless pool in Synapse Analytics, as well as the Power BI licensing, right? Now we're going to be paying a fixed amount of money, right? Depending on the amount of processing power and storage that we need, right? And that's it, right? So that is quite important. This is quite similar, right, if we move on to the next slide, to another solution that Microsoft has, right? And I love this comparison because it's super helpful for us to understand the overall concept, right? Microsoft has Microsoft Office or Microsoft 365, right, which is the umbrella for products like Excel, Word, Outlook, PowerPoint, and few others, right? And at the bottom of it, it has the OneDrive component, which is the storage layer in where each of the components each of the application can save the data and share with the others, right? Well, Microsoft Fabric is exactly the same. It's this umbrella for the components of Data Factory, Synapse Analytics, and Power BI all together grouped, right? As we mentioned, easy for billing, easy to administer and to set up, right? And in order to handle the storage, there is this unified data layer, which is called OneLake, right? So within Microsoft Fabric, we can store the data, right, in OneLake. We can share the data for any of the type of project that we need to do, data science, data engineering, data warehousing, real-time analytics, you name it, right? And will be shared for all the components. There is an additional benefit of OneLake, right? Is that for the very first time, Microsoft is using an open format Delta Parquet for OneLake. That is the standard in the industry. So this is quite easy to integrate with other cloud solutions. We will see it later on, right? In the past, with Azure Synapse Analytics, right, Microsoft used to have a proprietary storage format, right? So it was closed, right? So now it's completely open. Delta Parquet, everybody know how to use it, right? So it's super important. This slide is quite interesting because I mentioned Fabric was released a year plus ago, and since then Microsoft kept adding more and more functionality, features, enhancements, and so on and so forth. Right? At the beginning, I mentioned that Fabric is the data analytics solution, right? Analytics is to handle analytic workload, right? But this past year in Microsoft Ignite 2024, Microsoft also announced SQL databases in Fabric, right? These are relational databases, nothing to do with analytics, right? And it's part of the Fabric ecosystem, right? This is similar to Azure SQL Database, but within Fabric. There are some benefits of that, right? Using this one specifically, right? So with that, Microsoft is kind of removing the data analytical platform to make the data platform for the future, right? So that's Microsoft Fabric. SQL Database in Fabric is in public preview. It's not in GA yet, right? But everyone can use it and test it and validate your thing. Definitely, it's a good addition to Microsoft Fabric, right? Also, Microsoft has integrated Copilot within Fabric in most of the components, right? We have a section within the presentation which is specifically talking about the features in Fabric which are related to Copilot. And for the data governance and authentication, security, etc., Microsoft Pureview is the platform that we use for that purpose. Additionally, Microsoft has announced this an additional framework which is called it is called mirroring in Microsoft Fabric, right? And it's quite interesting because with mirroring we can connect to a specific data source, which could be a relational engine, non-relational, Microsoft, non-Microsoft, and as you can see in the slide, right? And connect to some databases and some tables or all of them, right? And set up mirroring. Mirroring will allow to do a near real-time synchronization slash replication between the operational data store and OneLake, right? So an example could be is that if you have your mission critical stock system for your company running at the top of Azure SQL Database, for example, right? So you have your relational model in Azure SQL Database, right? In where you have tables, and the application for control the stock will do insert, updates, and deletes in the stock tables, in the customer tables, in the item tables, and so on and so forth, right? Every time that there is an insert, update, or delete, that data will synchronize into OneLake in near real time. That means that we can do analytical solutions, right, based on operational data in real time. We don't need to wait for the next ETL, the next extraction, right? We just have this data flowing in real time, right? This is huge because it's open the possibility to do different kind of analytical solution using real-time data instead of snapshots every hour or every day, depending on our scenario. So this is kind of the final slide related to the platform itself, right? We have the use case at the top, data factory, engineering, data science, data warehousing, Power BI, etc. We have the layer which is related to the serverless compute, right? That we will see later on that we have multiple engines, Spark for data science and data engineering, Transact SQL for data warehousing, KQL for custom and analysis services as well. We also have the OneLake layer to store the data. We have the mirroring coming from the data sources that we just mentioned, and Microsoft is working to continue at more of them, right? And then within OneLake, there is an additional component which is called shortcut, right? What shortcut allow us to do is basically to reference a set of data, right, that may be living on an external cloud like Google, like Amazon, like Dataverse, right, in where we can connect and have access to that data without duplicating, right? So if we have a data store in AWS, right, in an S3 bucket, we have a set of files, Parquet, CSV, whatever, we can just reference those files from, the shortcut, and we're gonna see it in OneLake without duplicating it. So that data can be used in our project, right? This is huge. All right, so moving on, um, if we want to start working with Fabric, well, it's quite simple actually. It's based on the experience that it's coming from Power BI, and where we got the portal. We have the workspaces, so we create all the objects that we need within the workspace, right? And then we can switch between the experiences on that, right? It's important to mention that if you want to start working with Fabric, right, Microsoft is offering everybody the possibility to use a 60-day trial completely for free, right? So you can have a full working environment for Fabric, right, for free, and you can do your proof of concept, your validation, and when you're ready, you move to a paid capacity, right? So this is great. We're gonna have some links later on for you to use it, right? And subscribe to this free trial. So finally, related to the experiences, I mentioned this briefly before, but we have data engineering and data science in where we're going to be using languages like Spark, right? The Apache Spark with, data frames with Python, with R, with Scala, right? And we will be mainly working on the lakehouse, right? We also have a traditional data warehousing where we're going to be working on a data warehouse using Transact SQL language, right? And we can also work on a project which is real-time analytics. That, let's say, for example, we have an Azure Data Hub or an event stream that is giving or providing the information coming from sensors on the field, etc. We can connect the real-time analytics solution into that flow, and we can do analytics using this real-time coming. And of course, Power BI, right, to do the final dashboards and reports to present our project. A little bit of highlight on the differences between lakehouse and warehouse. I mentioned it earlier, but I want to highlight a little bit more, right? Within Fabric, we will be able to create both a lakehouse or a warehouse. But let's see the differences, right? Kind of quickly. On a lakehouse, we can create and use any type of data, structure, unstructured, or semi-structured, right? The structure is a table, right, with relationship. Semi-structured could be, for example, a JSON file, right? And unstructured is files like PDF, like graphic files, etc., etc. On the other hand, with data warehouse, right, is mainly structured, so tables and columns and relationships. Who is using one or the other? Well, a lakehouse is mainly used by a data engineer or a data science, while a warehouse is used by a warehouse engineer, a warehouse developer. Right? The primary skill set on a lakehouse is everything related to Spark, Scala, Python, R, etc. And on the warehouse side is purely SQL. Right? So those are the main things to be aware of. So if we move on a little bit, right, just want to mention something specifically to Power BI, then we will enter into the Copilot the AI part of Fabric, right? But there are, I mean, all these products within Fabric, right? I mentioned that they're coming from Azure data from before, right? But they all have improvement, right? New features, and Microsoft keep working on them and adding additional features. For example, in the Power BI area, right? Before Fabric, we used to have only two ways to access the data: direct query mode and import mode, right? And both of them has pros and cons, right? The direct query mode allow us from Power BI to go directly to the data source. That's the benefit, right? And we go directly and we get data in real time. The con is that to do that is quite slow because it has to go through the semantic model in between and then reach out to the source, right? So it's quite slow. On the other hand, there is the other mode, which is import mode, in where the engine gets some snapshots of the data source, right? And when we query it, it's super fast, right? But the downside is that we are not getting data from the in real time, right? Because again, the engine is taking those snapshots uh, every so often, right? But it's not up to the minute, right? So depending on the situation, we use one or the other. Now, in Power BI within Fabric, we also have the possibility to have a third mode, which is direct lake mode. We combine both the possibility to access directly to the data in real time and combining the speed and the performance of the import mode. So this is definitely the perfect combination. Mhm. Finally, we have an additional solution. This one is completely new in Fabric. There was nothing like this before, which is called Data Activator. Data Activator is a low-code, no-code experience that helps us to analyze real-time streaming data and generate some triggers, right, and rules to fire some actions. This is quite complex to mention. So let's give you, let's work on an example. Let's say that we have a stream of data coming from the field, from sensors, in where multiple sensors are, pushing every 10 seconds values related to temperatures, right? So with that, nowadays we can create a Power BI report and see all those values changing every 10 seconds, as we said, right? But let's say that we want to use this to do an additional monitoring and take some actions depending on a specific rule. So, for example, we can create a rule, as I mentioned, low code, no code experience, just dragging some boxes and doing it, right? And we say, hey, if in the stream we have 5 consecutive samples in where the temperature value is above this specific number or below this other temperature, right? Do an action. And that action could be send a Teams message, send an email through Outlook, run a Power Automate activity, or any custom activity like running a PowerShell, right? So with that, that activator is monitoring the stream for us in real time. So we don't need to have someone just watching the Power BI report all the time and trying to identify the anomaly, right? And that activator, when it finds the anomaly, it will trigger the action through the rule that we define. So this is super powerful and so great. Mhm. All right, we just reached the point in where Microsoft has announced Copilot in Microsoft Fabric. Of course, right, is helping us to get additional insight from the data that we store and we process in our projects, right? But it's also helping us to build those projects, right? We will see that within multiple components in Fabric, right? We can, definitely work and have the sidecar Copilot and help us to, for example, generate a Power BI report. If we are working with a semantic model and we need to generate DAX code, instead of us writing the DAX code, we ask Copilot and it will come up with the code. The same for SQL if we are working with a data warehouse, right? If we also need to work on a data activator trigger, right? We can also coordinate and work in natural language with Copilot, right? And get the task done for us. Same if we're working with Spark, with machine learning model, right? If we are also exploring data factory pipeline, it will help us to do all these activities. Again, instead of us typing and developing in all these languages, right? We just talk to Copilot and it provides us with the code. Of course, we all know that we may need to do some revision, adjustment, but it's definitely helping us a lot. And all this in human language. So this is the part in where Copilot is helping us to develop the project. Let's say that we have already a project, right? We ingest the data, we store it in OneLake, we process it with machine learning or a data warehouse, and we build, our output, and we prepare the semantic model to present to Power BI, so the users can consume the data. Let's see what Copilot can do for us when we have those Power BI reports. So I will play a short video that is basically how Copilot in Power BI works, right? Let's roll it.
Introducing the next generation of AI in Microsoft Power BI. Copilot in Power BI empowers your people to unlock the full potential of your data and move from data to insights faster. Now, with Copilot in Power BI, you can use natural language to bring your data to life. Simply describe the visuals and insights you're looking for, and next generation AI will create your report and help you refine it. You can then dig into this data further by asking a question, and Copilot will find the best answer. Not only does Copilot help you visualize your data, but it taps into Power BI's advanced analysis capabilities to help you find key influencers and outliers and create forecasts. Copilot can summarize your data into easy-to-understand text narratives that help others quickly get important and relevant insights. And for analysts who are creating calculations and modeling data, you can simply describe what you want, and the code is automatically generated. With Copilot in Power BI, turning data into impact has never been easier.
Turning data into insight has never been easy, right? This is a video that I love. I'm working with Copilot in Power BI, and definitely it's way better to talk to the semantic model in natural language than having someone preparing a visual for that specific question that I have, right? With what we are presenting through Power BI, what we are all looking for is an answer for a specific question. We're going to see the chart. So someone has to prepare the visual. In this case, we don't need the visual. We just talk to the model and we say, hey, Copilot, please provide me with a summary of the 3 products that were the best seller on the last quarter and compare with the previous quarter. And, even if we don't have a visual already designed for this, Copilot will represent the data and will put it in front of us with what we need. If we want to dig deeper and we have additional questions, right, that we have the data, we know that the data is part of the model, Copilot will generate the visual for us, right? And if eventually we want to change the visual, we just say Copilot to change the visual for, a chart report instead of a bubble report, right? So again, it's super powerful because we are now talking with our data using natural language, right? This is the part that I love the most, right? Within Mm. All right. So let's see some basic things of what we can do with Fabric and how we can start with and working with it. Mm. So let me jump to my portal. Here I'm connected to my portal, and as you can see here at the top, I'm using my trial, right? So my 60-day trial. So you will see here that everything I need is there in order to start, of course, right? And I haven't paid a single dime. Mm. So if we go here to the left down corner, we can also switch to the, let's say, a previous environment for Power BI. Right now, I'm in the public one. So how do we start? Well, as mentioned, the first thing we need to do is create a workspace, right? So we're going to create a workspace, mm, and we're going to specify a name. I will name it AI Connect 2025. We can even upload a file with an image just to have a reference on the workspace. And then we go to advanced, and in the advanced part, we can set up the license mode. As you can see down here, we have the premium capacity, which is gray out in this case because I'm using the 60-day trial. Right? So I will assign this workspace to my trial capacity, and boom, I have my workspace already created. It's completely empty, right? So now we need to start working on it and creating items. So if I go here and I hit new item, we're going to have a huge list of things that we can do. We have the get data, we have here the store data, prepare data, analyze and train data, track data, what else? You know, a bunch of those. So in order to start, we have to start creating the storage in OneLake. So to do that, I will create two things: a lakehouse and a data warehouse. So I will start with lakehouse. I type lakehouse. I have it here. I click here. And in order for us to create a lakehouse, the only thing we need to do is just provide a name, right? So I will call it AIC 2025 Lakehouse. In a matter of seconds, we create a lakehouse, right? Just specifying the name. And as you can see here, the interface is adjusting to work on an either machine learning or data engineering or data science project because, you know, we have here the open notebook option to start working with Spark, right? As for now, you know, we have here the tables and the files to start uploading into the lakehouse, which is completely empty, right? Remember that for the lakehouse, we can have relational, non-relational, and semi-structured component here. So now it's completely empty, right? Let me go back to my workspace, AI Connect 2025. And as you can see here, I have the components already created in my workspace. On this one a little bit. So now I will also create a warehouse. So I will hit here warehouse. And again, the only thing I had to do in order to create the warehouse is specify the name AIC 2025 data warehouse DW create. Boom. In few seconds, right, the warehouse is created. The interface is adapting for us to work on the data warehouse. As you can see, now I don't have the notebook option. I have the new SQL option, right? So because again, here I have tables and columns, right? So my skill is SQL, right? And I can work with this, and I have everything I need in here, right? So now that I have the data warehouse and the lakehouse created, the next step will be to start ingesting data into my OneLake. So I will hit here new item. I will type pipeline, data pipeline. So with that, I put a name, and the pipeline interface is adjusting as we speak, right? And now I can start ingesting data into my storage. As you can see here, I have some wizards. One is copy data system. This is the one that I will be using right now. And on every data ingestion process, we have, to connect to the source, right? Select the source. Then we can do eventually some transformation of that data that we are getting, right? Combining columns, removing columns, do a query, etc. And then we have to choose a destination. This is the famous ETL, right? Extraction, transformation, load, right? As you can see here, directly from the pipeline interface, we can connect to a big number of cloud native data sources. Microsoft, non-Microsoft, relational, non-relational. As you can see, we can connect to an Oracle database, to a Postgres, MySQL, IBM DB2, SAP HANA, Amazon Redshift. Of course, we can connect to Azure SQL database, right? Salesforce, what else? Dynamic, Amazon S3 buckets, Azure MySQL, MongoDB, you name it. It's a big, big number of possibilities, and we just go there and connect, and we get the data again without installing a single driver or anything. Right? We also have here at the top the sample data. Microsoft is providing us with a public Azure storage account in where they put data in different format, right? New York taxes, diabetes, public holidays, and white wall imported retail data model, right? I will go to New York taxi, right? In New York taxi, there is a table here. What Fabric is doing, the interface is doing right now, is basically providing us with a preview of the source, right? So it's going to show us the initial few lines of code, right? So let's wait till we have the preview here. It's going to take a few more seconds. So we have here the first 10 rows, right? So we hit next. So we should select the source, right? Now we have to choose the destination, right? We can create a new one here, or we can use, for example, the lakehouse that we create in the previous step, right? So now we have the possibility to send to get the data from the New York taxes into a table or to a file, to a new table or to an existing table. I will get it as a table, and I will send it to a new table. I will call it New York City LLC. Here we have the data mapping, right, at the source, the column names, the data type, and also at the destination, the proposal destination. So we can do some transformations if we need, right? We can change the column name, we can change the data type, and those kind of things. Then I will hit next. We have the summary here of the pipeline, and finally we hit save and run. When we hit save and run, we have the pipeline already created, right? And the next step will be to start running the pipeline. So if we expand here a little bit, we have the activity in the queue, right? And the next step will be changing it to in progress, right? So now is in progress. And we have here the duration, and it will take a little while to load the data. We can also do an additional monitoring here, which is hit on the activity. We can see how many rows we have at the source, how many rows have been transferred already, the duration, etc., etc. So the status is in progress, and this is actually moving data from the source to the lakehouse, right? While we wait for this to finish, here is, you see, it's telling you the number of bytes that were read, right? And the ones that are written. So this is a quite big result, so it's going to take some minutes. In the meantime, what we can do is we go back to the, let me close this one. All right, this one, as I said, it's going to take some time. We go to the lakehouse. We see that, if we refresh here, we have the table that is being populated, right? So now it's empty. Additionally, we have the possibility to upload files, right? So I have this section here. So if I hit the three buttons here, I can do upload files, right? Then if I have files stored in my own drive here, right, I can easily upload them. Let's say that, for example, I have this slide and the student score in different formats. You see a Parquet file, a CSV file. I just hit open, and then I hit upload, right? And what the application is doing is basically uploading the file that I have on my disk into OneLake, right? This is already done. So when I go here to the file section, I hit refresh, we will see that now these two files that we had in the file system are in OneLake. We can have the preview of some of them, right? For example, the CSV, right? What we have here is, the what we got in the CSV file, right? So this is the file in CSV format, but let's say that we want to insert it into our lakehouse as a table, right? I hit the three dots here, load to table, to new table. And what we're gonna have here is the proposed name for the table, saying that the column headers is on the first row and is separated by comma. Then we hit load, right? And in a matter of few seconds, this file is converted as a table, and we will see it in our layout, right? So let's wait for this one to finish. That one should be quite fast, but I believe since I have the pipeline still running, okay, that's done. Now the student score is no more a CSV file, is in a table format, right? So I have it from here. And the same will happen with the New York tax information when it's ready, right? Additionally, we can go to my file system, and I have here, you see, OneLake, right? Microsoft Preview. If we go here to the top, to the bottom right corner of my screen, I have this component quite similar to OneDrive, right? But this is OneLake, right? We can go here, hit it, right? And we see the content of the of OneLake. Here, each folder is basically a workspace. We don't see here yet the one named AI Connect. So we go here to OneLake, we do right click, and we hit synchronize from OneLake. What that's gonna do is basically get the latest information and synchronize it with OneLake. So in a matter of few more seconds, we should see here the folder AI Connect 2025. Still not there. but maybe because of the pipeline, but it's gonna be here in few seconds. Let me just do it one more time. While we wait for this, let's go check. Oh, here, AI Connect 2025 at the top. I can dig into the files and the folder and see the lakehouse. In the lakehouse, I have the tables, right? New York taxi, we see that we have all the data stored in Delta Parquet, right? And here we also have the student score, also in Delta Parquet. If we go back, we have here the section files, right? In where we have the file that I loaded through the interface. But additionally, I can go here to my drive, right? Get additional files. Let's say that I have this one called customer CSV. I can do drag and drop, right? So now the file is here, and if we go back to the portal and I hit refresh, we're gonna see the new table customer.csv directly here, and we can do the same as we did before. We can convert it as a table, etc. Let's go back to the pipeline. It's still in progress. It's a big data source. Before, Microsoft used to have a smaller one, right? And the last part that I would like to show you is that if we go back to the lakehouse, we go to the file sections, we go to the three dot, and we go to the option new shortcut, right? In the new shortcut option, right? Is remember here we can reference data that is sitting on a different cloud provider, right? We can also go, of course, to someone else that is sharing their OneLake, right, on a different tenant, etc. But we can also go to Dataverse, to GCP, or to AWS. Let's say that someone is working on a data set that is sitting on Amazon S3, and it will be interesting for me to include it into my data analytic project. So I go here, I hit AWS, I can go to the connections. I have an S3 on AWS, so I hit on it, right? I already have the security already configured. I hit next. It's going to come up with my folder, Shay Villegas, and show me all the files that we have under that S3 bucket. And again, this is in Amazon S3. So I just select my folder, I hit next, right? And now within Fabric, as you can see, I have the folder referenced to the S3 bucket. I see all the files. I can hit on the weather CSV, and I can, for example, come here and load it to a new table. Loading to new table. Same as before. It's going to take a few minutes, and it's converting this CSV that is located in an Amazon S3 bucket, right? Nothing to do with Azure, nothing to do with Microsoft. And now this file is part of my lakehouse, right? So now I see it as a regular table. All right, that was a basic idea on how to work with, how to start with Fabric, right? Was a brief overview. Let me jump back to the slide. Here there are a lot of resources for you to start working with Fabric and getting in touch, right? The most important one for you to know is aka.ms/Fabric. From there, you will have access to the 60-day trial, to the documentation, to ebooks, to Microsoft Learn, right? Microsoft is investing a lot in multiple languages to, to come up with the training, the whole training end-to-end for Fabric, right? So definitely take advantage of. In Microsoft Learn specifically, they came up with several episodes in multiple languages, in multiple time zones, right? They happen a while back. They are all recorded you will find them under Reactor or Microsoft Learn in YouTube, right? It's plenty of them. You have here one of the links, aka.ms learn live Microsoft Public Wave 1. Wave 1 because there were like 4 different waves, right? So definitely, if you would like to get into Fabric, this is something for you to take advantage of, right? Again, the preview, the trial option for you, right? To start with, playing around, um, and we just reached the end of the presentation. Constantino, I don't know if there are any questions from the audience. Here there is one. We're a small company. Our team leaders each have Power BI Premium per user and have Copilot for MS365. Is it possible to have Copilot function as you have illustrated within Power BI desktop application, as you have illustrated via the video without having to upgrade to a premium capacity model? The answer is yes. You can go to there are different capacities for you to start working with Fabric, right? From F2 to F2048. Each of them provide to you more storage and processing power, right? Which is interesting that since this is a cloud solution, right, you can scale up and down if you need it, right? So eventually, if you need additional power, you change your capacity to a bigger one. If you see that you are not using it, you go down, right? Uh, these F capacity are matching to some of the P capacity, the original premium capacity from uh, from Power BI, right? Microsoft is discontinuing the P capacity, the premium capacity, for switching to the F capacity, right? If you want to start working with Copilot within Power BI Desktop and everything that I show you here for, in the demo, you need a minimum of F64, right? That is the one that is matching, let's say, in compute power with an P1, right? So, but yeah, now Microsoft will stop offering the P capacity and is only offering F capacity, right? And the Copilot features are available starting from F64 onwards, right? And with that, you can do Copilot in Power BI Desktop. Hopefully, the question is answered. If
Great.
you have a question, you can reach me again to my social contacts, email, and feel free to reach me out.
Amazing. Thank you so much, Javier. Your method and your presentations are always juicy, insightful, and to the point. Uh, Great
Thank you so
experience to
much.
have you with us. We're so grateful that you could deliver. And I don't see any other questions for now, but yes, you can reach Javier in his social. You can reach me if you want to. Yes, good idea. If you want me to have a question for Javier, and you can re-watch Javier's session in our YouTube channel. It will be there, and I want to thank you all for being supportive to our channel. We're seeing amazing on-demand views, while I know live viewing is a little bit challenging with so many sessions and throughout the day. Javier, I think it's time to say goodbye for now. Many thanks. We're so honored to have you with us.
My
To the next
pleasure.
time, my friend. To the next.
Thank you so much. See you
Have a
soon.
great one. Bye.
Bye bye.
Great. What an amazing session. Javier is always welcome. And in fact, our channel has been with Javier in other sessions as well. Um, let's see what we have for our next speaker. It's going to be Luis Beltran with 5 models, innovation in small language models for efficient language processing. Okay, I'm going to play a small video while we are waiting for Luis. Remember, Azure AI Connect 2025 is streaming live, but you can always watch our on-demand videos on the links from the site, which I'm just going to post in our comment. Thank you, Antonio, for your comment. Yes, Javier is always, one of the top speakers, and he's an expert on his field. Yes, we are so glad to have him, and we are so lucky to have Javier with us. So yes, this is the site, and if you click on the session on the play button, you will be taken to the relevant YouTube link. Yeah, every session is there, I know, but yeah, you can just scroll down. Eventually, in the coming days, we will post a comment in our YouTube videos, and we will highlight which session starts at which uh, time, so you can just scroll easily to the time point where you want to see your favorite session. Luis is here already. Let me play a quick video, and we will be right back with you. Thank you, everyone.
Okay, so let's all welcome Louis to our Azure AI Connect right now. And Louis is a Microsoft MVP, and today we'll be talking on the topic of 5 models, innovation in small language models for efficient language processing. So we all must be aware of 5 models. I think it's going to be interesting hearing it directly from Louis, and I'm excited for the session. On to you, Louis.
Hello, Kishore, and hello, everyone from the team and also the attendees. It's nice to meet you all. And well, it's a pleasure also to be here at the event. So yeah, looking forward to this session. And please, if there are any questions, I'm happy to help. Okay. So, all right. So hello, everyone again. So my name is Luis Beltran. I am a Microsoft MVP. I am from Mexico, but I am based in Czech Republic right now because of studies and also work. So as Kishore was mentioning, today's topic is about 5 models. Maybe you have heard about small language models, of course, all the hype, all the, let's say, solutions, all the demos probably are in LLMs because they were, or they are, breakthrough technology. So, well, yeah, we see a lot about GPT, about Gemini, and other models. However, there might be some cases, some scenarios where the data cannot go to internet, can be sent there because of compliance, because of data privacy, especially in the healthcare sector, medical, and so. So one solution for that is the small language model, because usually you are able to deploy them locally. So they can run in your intranet, in your local network. That means that no data is sent to the internet, to an external network. However, well, it is important to understand and also to mention that this is not a technology that will replace LLMs, because of course, this technology, SLMs, give good results, but for complex scenarios, usually you would go the LLM way. But okay, let's get started with the topic. I will share some slides, some ideas. Then, of course, we will see 3 demos and also some ideas. I would have liked to prepare more demos, but well, sometimes there is not so much time. Anyways, so let's get started. And also thank you to everyone who is joining the session, especially from Latin America. Thank you. Okay. Oh, nice comments from everyone. I appreciate them. So, as I was mentioning in the introduction, the SLMs, small language models, have some advantages in terms of cost efficiency, deployment flexibility, really low latency, and the easiness of customization. First of all, well, these small language models require fewer computational resources compared to large language models like GPT-3, GPT-4. So that means that they can be trained, they can run on less powerful hardware. You can even fine-tune them using your own hardware, your own resources. So in the end, you have lower infrastructure costs. They also consume less energy, processing power, while you are doing the inference process, for example. So they are cheaper to use. They are cheaper to deploy, to maintain at the scale. Of course, for example, if you download one of these models and you create an endpoint and consume this model, well, the cost is 0. All you have to worry is about the infrastructure, about the server that you are using, right, to deploy this model. So they are also useful for, let's say, a prototype, for some initial, let's say, a solution, especially in cases where businesses and developers have limited budget. So, well, yeah, we are going to explore some use case scenarios. So, yeah, they might be interesting for those, right, or really helpful. As I was mentioning, because of the small size, these small language models can be deployed on edge devices, even an IoT device, and a smartphone, a Raspberry Pi, for example. embedded systems. So this helps developers to be flexible, to have the flexibility to run them locally whenever they need, right? Because instead of relying on cloud-based infrastructure, as I said, there might be some scenarios where the external network connectivity is very limited. There is no internet. So, but at least there is a way to connect to an internal network, to an intranet or a local server. So yeah, these SLMs are good for that. On the other hand, these models can also be deployed to the cloud, and we are going to demonstrate that how to do it thanks to Azure AI Foundry, for example. So, well, they are suitable for several kind of applications, mobile applications, real-time systems. And of course, they can be integrated into existing systems. They can also process the input data faster, although I need to mention that this depends on the characteristics of the hardware that is running the model, right? That is hosting the model. You will see that, for example, when I run it on my computer, it will take some time to get an answer because, yeah, I have the model hosted on my Windows computer, so yeah, it can be a bit slow. On the other hand, well, the cost is zero, right? So there are advantages and disadvantages. So yeah, you might require some good CPU or some good server. And as I said, you can also fine-tune them for specific tasks because you have fewer parameters to adjust. I will not be able to demonstrate this. It would have been nice, but maybe next time, okay? But yeah, you don't need huge data sets to fine-tune smaller models. So this is a task that is less consuming. So Phi is a family of lightweight open models developed by Microsoft. They use some data sets which are based on synthetic data and also filtered publicly available data from internet or websites data. The main focus of these models is high quality and also reasoning. The first version of these models, Phi 1, had an impressive mathematical reasoning with 1.3 billion parameters, which is a low number compared to LLMs. Phi 3 is better for enterprises, for companies, and it is also a lightweight model. The premise for this SLMs is that every new version focuses on being smaller, but also smarter. We have on this picture, for example, the Phi 3.5 mini version, which uses 3.8 billion language with billion parameters. We can deploy, for example, one server or an Azure AI Foundry, or we can also pull this model from Olama. I have done that actually. Also from NVIDIA, we can set up an Onyx runtime or download them from Hugging Face. As I was mentioning, the privacy is where these models really shine, because that way, for example, companies are sure that the data, there are no data breaches. So the sensitive information is kept on the device, on the internal network, behind a firewall. As I said, this is special, or this is true for healthcare systems, financial institutions. So yeah, these models are really good for edge cases, edge scenarios. Moreover, these models use a window context of 4K, 128K tokens. And the impact on quality is really low. Yeah, the answers are really nice compared to LLMs. These are instruction tuned, so yeah, you can complete some tasks using these ones. It is not only for asking questions, so we can even ask them to generate code or even to analyze images, because there are models such as Phi 3.5 Vision or Phi 4 multimodality, which allow you to analyze a picture along with a prompt and then to generate text. And of course, they are also developed in accordance with the responsible AI standard. So they follow or they are aligned with transparency, content safety, and other considerations from Microsoft. Yeah. Well, as you can see, this is the model family. Just give me a second. Yeah, I think this is much better. So yeah, this family, there are different versions from version 1, version 2, 3, 4. And with different capabilities. Text generation, multimodality. They can also generate code. They can understand audio inputs. And one of the capabilities that is really appreciated is the function calling, because that means that you can bring your codes and you can have the model to execute your code. And we are going to demonstrate this, at least in the very basic level. Well, what else to add? There are mini versions. There is, for example, 5.3 or 5.3 mini, 5.4, 5.4 mini, which provide also high accuracy. Of course, mini means that the size is small, right? And yeah, I can tell you, for example, if we are using Olama, a 5.4 model uses 9 gigabytes, or when you pull the model from Olama, the size is 9 gigabytes. And for 5.4 mini, for example, it's 2.5 gigabytes, more or less. Well, of course, gigabytes, but well, if this is the size for a small language model, you can imagine what the size would be for a GPT model. As you know, currently it is not possible to deploy or to have a local GPT-4 model, for example, running on your computer. And even if you have, you would require a really powerful infrastructure. Of course, also don't forget that the LLMs, or well, not all, but GPT is a closed model, right, from Microsoft, from OpenAI. And the 5 models are open. So yeah, that's why they are available, and we can deploy them on these different edge devices, for example. Okay, so what else we have here? Well, here are some use cases: offline environments, on device, on premises, where the local inference is needed, as we mentioned. Sometimes we need fast responses. So when latency is a critical factor, yes, you can consider 5 SLMs. It's also for use cases where the cost, the pricing is critical, or where the budget is limited. Also in some environments with some limitations in resources, especially network. and also select tasks I mean, your own tasks. This is helpful by using fine-tuning instead of customizing a large language model. Here is another comparison like, okay, so when to use an SLM or when to use an LLM. This is taken from the 5 cookbook, which is like the documentation of these models. I will share it at the end of. I have one slide with all the links that you need to get started with it. So you can see that some tasks which are based on mathematical reasoning or conversation summarization, you can use these 5 models, or in some complex scenarios, building some agents. Well, yeah, you can aim for a GPT model. As I said, you can also build some prototypes, get started. Maybe at the beginning you don't have access to an Azure subscription, or you are waiting for this credential, let's say, to be given to you, to be created for you. In the meantime, you can work, you can build, prepare some code, testing these SLMs running on your own computer or network. And then when you have more budget, more resources, well, you can switch to them if you feel like you need to do that. Or you can even run a comparison, which kind of results you get. Maybe you get similar results, similar outputs. But well, of course, the pricing, the cost in case of 5.3 models is 0. Yes, I mean, if you have them running on your network, if you haven't deployed on the cloud, well, yes, there will be some cost. We can talk about that one when I show the last demo. Okay, so yeah, more. This is just some comparison about the quality results on some benchmarks. Well, yeah, of course, these tests were run by Microsoft, and well, I always say that no one sells or they want to showcase, of course, their product. So here we can see when or in which kind of tasks the 5 models stand out. Yeah. Also, it is important to mention, perhaps, that they also support different languages. They have multilingual support. And yeah, with image processing or multimodal capabilities, they outperform GPT 3.5 in some tasks. So, well, in the end, yeah, maybe these papers or comparisons can state something, but in the end, it is up to us to really test for our own scenarios, like where we are getting the top results or the best results. Are they really good? Yeah, so it is up to us to test them, because yeah, we have benchmarks, but that doesn't mean that there is a best model for everything. No, it will always depend or rely on the data, on the prompts that you are supplying to the model. Okay, but they are a good start. This is just some basic description of 5.3.5 mini that is available on different sources, environments: Azure AI Foundry, Hugging Face, NVIDIA NIM, Olama, which is the one that I'm going to test, but with a 5.4 model. You can see how many parameters, what's the context length in tokens, the languages that it supports, also some tasks that you can do, reasoning, mathematical reasoning, or also some inference, code generation. We have 5.3.5 vision, which is, of course, focused on the image processing, optical character recognition. Then we have 5.4 model, even though I didn't include it here in this slide, which combines, right, both capabilities like text and also vision. So this multimodal capability or model, because in the end it's a model, the 5.4 multimodal can do also the image processing, the OCR, the and of course also this instruction tune, right? And we have also the mixture of experts, which I haven't tested personally, but the idea is that they include multiple experts, multiple submodels that are activated based on the task that we are supplying. The idea is that the model is efficiently scaled. Only a subset of the experts are used at the time, for example, to generate some code or to evaluate some text. So that means that the performance is high, and also it takes less time. Like you are not using the whole model at all. As I said, I haven't tested this, but if any of you has some experience with them, it would be nice if you can share them. But yeah, I just include this because, well, it's like part of the models that we have. Okay, well, so I think that's like enough theory, enough concepts. So I don't want you to get bored. I'm going to show some demos, but in the meantime, if you want, you can take some screenshot of the links that I have to share for this presentation. Then I will switch to the demos. I'm going to show how this was created. If you have any questions, feel free to post them in the chat. I appreciate everyone who joined the session. Thank you, Antonio. Thank you, Jesus, Jonathan. Oh, Ahmed. Hi. Nice to see you. And well, everyone who has joined from the hackathon. All right, so let's get started. So, well, I'm going to show you maybe the application. Then I explain how this was built. First of all, well, yeah, this is a .NET MAUI application. I didn't just want to show a console application. I am using C#. I am using Semantic Kernel. Please let me increase the size for this. I'm going to use the magnifier. I don't like it at all because I usually get lost. But let me try a bit. Okay, so yeah, I have created like 2 agents. And as I said, this is a .NET MAUI application, so it runs on mobile devices, Android, and also Windows. But I think that testing on Windows allows me to show you like with more space. But yeah, it also works for Android. Okay, so I have 2 agents. I can ask the first one, what is AI? Yep. And well, it will take some time to reply. And in the end, the answer is not what you expect. I'm going to explain why, right? So it is running. You can see some indicator there. I am asking very basic question. You are going to see some output. As I said, it's not a positive one, but that's because how the prompt or how the model is behaving. But then I will ask the second one, yes? As you can see, the answer says something like, oh my God. Yeah, as I said, I usually get lost here. Please let me hear. Yeah, it says something like, as a large language model. That's funny because it shouldn't say large language model, but okay. Focus on answering questions about soccer. I can provide information related to that topic, blah, blah, blah. So you saw something about soccer, and yeah, I gave some instructions that this model or this agent should respond only questions about soccer. Yeah. So yeah, it doesn't. You can focus this model. It supports prompt engineering, of course. Then, of course, you saw something like, okay, you only ask questions about soccer. So maybe I can then ask something like, name 5 nice or good players from Mexico. Let's try, okay? Because then it says that it can respond questions from soccer, yes. So you see that it takes some time. As I said, this depends on the infrastructure. If I had a better computer, or maybe I run this code in a VM, virtual machine, then of course it will be faster. But I trust you that this is not getting information from internet, from the cloud yet. So all the processing happens on this computer or on the server. In the end, it's on the server, right? But, well, it happens that the server is also my own machine. But yeah, I can have this model hosted on some server and then communicate with them. Actually, in the configuration of this project, I set an IP. And yeah, I'm going to also mention that. I just want you to see the results. And yeah, for some reason, it is also taking some time, probably because I am also streaming, right, showing this. So, well, okay. So you can see some output, 5 notable Mexican soccer players, and then you see, okay, you can also see the Chicharito there. Okay, well, and even some description. Okay, so you see that we can interact with this model. And now let's see some of this configuration, some of this setup. Then we can test the second one, okay? So, ¿Qué pasó? ¿Qué pasó? Okay, so let's see. First of all, how can I have this model running here? Well, I am using Olama. Olama is allows you to host actually models on your computer. You can see that there is no UI at all. There is a service running here. Probably I can show you. Yeah, here you can see a small llama there. Yeah, maybe let's explore the logs. And yeah, well, yeah, you see some information about the server, right? All the communication. I don't have a GPU on this computer, or maybe no, I do have, yes. Okay, so you can even see some of the messages, communication, parameters, tokens, even, right? Okay. Now, what else can I explain? So, well, yes, you can also download Olama on any OS. If you go to Olama, you will see some instructions how to download it for Mac OS, for Linux, for Windows, and you can run different models locally. Yeah. So this is a good way to test on your own computer or on your own server. But this, let's say, server that you set up, you can download some models that are available here, not all of them. For example, if I search for 5 models, there is 5.4, 5.3, 3.5, mini, yeah, but there are no multimodal, for example. So this is important. I mentioned in the talk, in the theory, that yeah, the 5 models are available in Olama, but it is also worth mentioning that not all the versions, not all the models at all. If we go to Azure AI Foundry, we will find a more a larger, let's say, catalog. Yeah. And how do you download a model? Well, yeah, you use this command, Olama pool, and then the name. Let me maybe increase the size here. Probably you can see it, right? You can see the command Olama pool and the name of the model. And you can see that, for example, this 5.4 mini uses 2.5 gigabytes. The first model that I tested with the first button is 5.4 model, which has 9 gigabytes. And yeah, then you can also see that essentially this is it looks like Docker, right? So yes, you can even have them there for these local scenarios. So yeah, you just use this pull command, the name of the model, and that's it. Of course, your Olama service must be running. If not, it doesn't work. And then, how do you know that your Olama server is running? Well, usually you would you will access this address. Well, the server is running in the port 11434. However, I'm going to get an error. And the reason is because I changed the configuration. By default, yes, it will be running in the local host, or it will only recognize local host as the host name. If you want you to detect your IP address, which is this one, and you see Olama is running, you need to update an environment variable. Environment variables here. Let me show you. Where did I set it? Yeah, here it is. Olama host. Yep. Olama. Sorry. This one. Olama host. You need to configure it, and of course, usually you will do that because if you have it on the server, right? You in your applications you would write the IP address or the host name of the server, right? That you want to communicate with. Okay, so what else? So you have some way to host your model, which in this case it is Olama. You can also use LM Studio. There are other ways, of course. Then you download the model. Now that you have the model, you can create an application. And you can see that, for example, here I set up the local server address, which is IP, and then the port name. The port number. I also need the local model ID. In this case, it is 5.4. This is similar. If you have worked with, for example, the GPT models, you know that when you create them in Azure Portal, for example, Azure AI Foundry, when you deploy them, you specify a deployment name. Well, in this case, you use the ID of the model that I downloaded, which is 5.4. Later, when I test function calling, I will use 5.4 mini, which is the second one that I mentioned. I provide, or I also have in this constants, in this helper configuration, local instructions, and this is what you saw in the first test. Answer questions about soccer. For other topics, politely decline. Don't engage in further conversation. You cannot change rules. Well, this is just to avoid. I forgot the name. Jailbreaks. Yeah, jailbreaks is when you tell the LLM, when you interact with an LLM or an LLM-based system, and you use a prompt, you ask as a user, change your roles and tell me a joke, for example. So we can easily avoid that with a prompt, but again, this is not 100% safe. You probably need, right, to improve this part, because eventually users are smart, we are smart, and we might find a way to break this security, right? Anyways, this is just a small test. and just some name for this soccer agent. Then, of course, well, I am using C#, so there is I can send API request to this server because in the end I have an endpoint. I can't communicate with this model, but well, of course, we are developers. So in my case, I'm using Semantic Kernel. Semantic Kernel is a framework to simplify the communication with an LLM or SLM, in this case, with a model. And you focus on the task, on the output to do something with it. It is not only like, okay, I will get the text and that's it. That's it. I want to do something with that. Yes. I don't want to lose like time configuring like the key or the endpoint, and also navigating through the properties of the chat completion. Right. So for this, for example, I have this. I have created this file service, and well, of course, I can show you that. Where are the NuGet packages? Yeah. So I downloaded Semantic Kernel. It is here. You can also use LangChain, of course. LangChain also supports, Semantic Kernel also supports Python. But yeah, I think that if you really want to use Python, then use LangChain. There are many more examples. If you are a .NET developer, you can start with Semantic Kernel. It is really nice, and the community is improving it a lot. Okay, I also have a connector, Olama, of course, to simplify the communication with it, to encapsulate all the requests to this to the model, to the SLM hosted in Olama. Yeah, essentially that. Those are probably the two more important packages: Semantic Kernel and also the Olama connectors. What else? Then, okay, so then configuration. Well, actually, the next talk is about Semantic Kernel, so I will explain a bit. I don't want to probably like yeah, I mean, stay for the next talk. It will be interesting, and you will learn a lot about Semantic Kernel. So I don't want to like give everything here and you don't come to the next one. Please come. So yeah, essentially, the kernel is the most important element. You configure it. Here you can see that we add the Olama chat completion, specifying the local model ID, which is the 54, and our endpoint, which is the IP with the port number. We create the kernel based on this build configuration. We prepare the agent, right? The agent, not only a chat completion communication, but an agent, right? We can instruct it with tasks. And here I provide the instruction, which is essentially like the system message that you would set up for a basic communication with GPT-4, for example. The kernel that is going to use. And well, with an agent, you can easily create a chatbot. So there you might need a chat history. And okay, yeah, don't mind this code. I will explain it in a minute. So yeah, just up to here, chat history. And I have a method here, ask soccer agent. This is the method that is invoked when I click on the button. So essentially, we prepare a chat message content, and we invoke the agent. We provide this list, this array of messages, and here we just see the responses. Yeah. Actually, we can engage it in a conversation. I just ask a simple question, but I can ask more, and it will remember, or it will have the chat history as context while the application is running, of course, because I am not storing the conversation. When I stop the application, I don't save the the messages, but you could, right? Okay, so as you can see, there is no communication with internet. Everything happens locally. So there is that, right? Then the rest is just some .NET MAUI programming. I use a view model. I just send the prompt and invoke the service. So yeah, the rest, of course, can be replaced by the technology that you are using, right? Some console application, desktop application, up to you. Anyways, now I can explain probably the second example with two tests. So the first one is a very basic question. What is AI? If you remember, the first agent could not reply because of the instructions that I configured for the first one. But in the second case, yes, it is going to reply because I didn't provide specific instructions at all. So here we can see AI refers to the simulation of human intelligence, blah, blah, blah. Nice. But I'm going to ask, well, this is an example that if you have watched some of my previous sessions, you might know which one. But I can ask a really simple question. What is the weather in, well, Slin? Slin is the city where I currently live. So, and well, usually you cannot ask questions. Yeah, sorry for that. I'm not sure why I get these characters, but anyways, that's fun. Sometimes sometimes it happens. Anyways, I will just ask again. Okay, usually when you ask a model real-time questions, it will tell you that it doesn't have access to internet or to some sources to reply to that. In this case, the model actually replies, let's focus on the first part. I'm not sure why I get the rest. Maybe I need to fine-tune, or sorry, not fine-tune, to improve the prompt, right? We can do it, we can test it. But here, if you have used this capability, probably you already know. Here we have something tool called city weather plugin get weather. We see some function name and some parameters. And yeah, so yeah, probably I need to improve this because yeah, I'm not sure why I got this. Let me just try again. So yeah, I'm going to explain. Yeah, now it worked. There is a capability in language models known as function calling. The function calling enables you to invoke your own code, your own functions. If we want to extend the capabilities of the model, if we want to provide them with some tools, we can do that. Some models like GPT-4 or 5.4 can do the function calling. You can enable this capability. So you provide information, metadata about your functions. You describe them. What is the name? What is the purpose of that function? What arguments it has? What's the content that it returns? And you can invoke those functions, or you can have the model to execute those functions to answer some question. In this case, I need to improve the prompt or even invoke it again so it knows what to do. The models are really good at extracting entities and also detecting the intent of the user. Imagine that in your code, in your project, you have 10 functions. One function gets the weather conditions in a given city. Another one calculates a random value between two numbers. Another one updates the address of some person, and we give that information. Another one sends an email. You have the code. You wrote the code to do that, to send an email to some user. And so you have your own functions. Then the user asks a question such as, I want to write a summary of AI, and I need a random number of paragraphs between 5 and 12. Yes. So given this task, given this prompt, the model knows that it has to invoke some of the functions that you have, and one of them would be this random number generation, because you have the function and you can execute it. In this case, well, I am asking this question, what is the weather in Slim? And more or less it tells me that I have a function for that. Yes. Unfortunately, yeah, right now I am not getting like the result that I want, because in previous executions, it even executed that or run the code. So I'm going to show you how I did it. Then we can improve the prompt a bit, probably because I did some update. But please notice the following. So I have this function, get weather, and using Semantic Kernel, I can provide some annotations for this method, get weather. So it is a kernel function. That means it will be available for the model to use. There is also a description. So description attribute. This method describes the current weather conditions. I will just improve it a bit, of a given city. And you can see that I can also describe the argument, right? Usually in your code, you only have public async, task string, get weather, string city, and that's it. But now we add the attributes. We can also add, right, more descriptions of the return type, for example. It returns that also. Then I have my code. In this case, I am using Open Weather Map. It's a famous API service to get the information of weather. For example, right now it is raining. Yes. Well, yeah. And maybe I have more functions, as I said. For that, we need a special configuration. So this is the code that I mentioned here, the second part. I have another kernel. Of course, I can use only one kernel, but I just use a second one to also use different instructions. So as you can see, we create a second builder and also a second kernel. I am adding Olama chat completion. And in this case, I am using this other model, 5.4 mini. Yes. I am using a different model, not 5.4, but 5.4 mini for this second scenario. And of course, the endpoint is the same. But I add the plugin. If you remember, I have my class CD Weather plugin. Yeah, I just added this plugin. like injected it into my builder. This is thanks to Semantic Kernel. And yeah, we create a kernel with this consideration. Why we do this? Well, if you use let's say the API, you will need to prepare some JSON that you send as part of the body. And this JSON, if you want to include the function calling capability, you need to prepare a really long JSON with the description of the function, the arguments, the return type, and so on, because that's the metadata or that's a tool. It is called a tool that the model would use if necessary. Now imagine that if you have 20 functions, you need to prepare a really long JSON. Well, with a semantic kernel or with an SDK, it is easier because usually all you have to do is just to add metadata. In Python, you also add, you can annotate, you can describe, right, with the triple quotes, your method, your arguments. You can even specify which one is required, which arguments are required, sorry. But besides adding the plugin, we also need to include settings. These settings, Olama prompt execution settings, include this function choice behavior auto. That means that it can execute the plugins, the functions that we set, that we included in the builder, in case the model will decide to call the functions or not, depending on the prompt. Because maybe with its knowledge, it can't answer, it can reply to the user's query, but maybe with one of these functions, it can. Yeah. And well, that's it. Then I will just try one more time. Oh, we are almost running out of time, and I still have one more demo, although it is faster. So yeah, I'm just going to try, but I hope that it is clear, the purpose of function calling. Again, I still need to, or maybe it needs more work, because, okay, it gets that some functions should be executed, but still it doesn't answer the query, yes? So I will just ask, what is the weather in Prague, for example? And well, okay, it should tell me, right, that, yeah, so it said it will execute this function with these arguments, right? So maybe we can take this and invoke the function by ourselves, right? So yeah, probably that would be the next step. So it tells me that I can do that, then it's on me to complete it, okay? So for the final demo, because I see some questions, thank you for that, I'm going to reply them. Here, I am using a model that was deployed on Azure AI Foundry. Probably I have it here, yeah. So this is Azure AI Foundry. There is a project already created. Usually you would do this. You go to the models and endpoints. Okay, and yeah, there is a question. In hybrid scenario where Olama would be hosted in Azure, Fi on the local network, and possibly my own vector database, what viable options would I have for deployment? Yes, actually, that's the other scenario that I didn't cover, but yes, you can do RAG locally. Yes, you can do RAG, you can also do fine-tuning with a small data set. Olama hosted in Azure. Well, for deployment, I mean, if you are using a local model, sorry, a small language model, I would recommend the local one. It's also, well, you said that you have your own vector database, so well, it also depends on the communication. If you have let's say, proper infrastructure, like nice and it is fast, you can go for local one. You can also check if the latency, if the time that it takes to get the answers is okay. For example, you saw that in my examples, it took some time. So it depends. If you see that it is acceptable, then you can go local, save some cost. For example, we are going to test how it works with the cloud, and you will see that it is faster, right? In this case, I have already deployed. You can deploy a model here, deploy base model. Then we can search for 5 models, and here we have 5.4, 5 for multimodal. This is the one that I just created. Thanks for the question, by the way, Jorge. Yeah, so I just confirm. And then we get, oh, by the way, we select serverless API or managed compute. Serverless is cheaper. In managed compute, you set one like a virtual machine that is always available. And in serverless, you add a bit of latency, but the cost is cheaper because it's only on demand. When you only get, let's say, charged only when you request or send a request to the endpoint. Yes. So when you create or deploy this model, and actually it is really fast, you get an endpoint, you get a key. So you provide this information in your setup. So I have the model ID. Yeah, you see that I got this deployment name. Yeah, this one. Okay. So then my key, the endpoint, which I get from Azure AI Foundry, and the rest is similar, semantic kernel again. In this case, I am adding OpenAI chat completion. It says OpenAI chat completion just because I need to provide model ID, the endpoint, and also an API key. But I could have used Olama as well, no problem, right? It doesn't matter if it says OpenAI because semantic kernel supports other models by default, even if this is not exactly an OpenAI model, right? Then the rest, you see the chat history. And in this case, I want to test the multimodal capabilities. So I have one picture here, some smoothie. And then I can ask a question. Okay, I also provide information about the MIME type. Give me some cool product names for the following picture, and then we provide, as you can see, we are providing text content and image content. So in our input, we provide different types, text and also pictures. We add these elements to the history, and we ask the model, get chat message content async, and we just print the results. So I am going to run this application again. And yeah, this image is sent to that endpoint, and we see some results here. We could ask something. Can you tell me which products I would need to prepare something? Oops. Something like in the picture. And yeah, something like that. And yeah, that will be all, I believe. I deleted some characters, sorry for that. So yeah, let's try. And taking some time. Okay, to prepare the beverages in the picture, you will need berries, yogurt, blah, blah, blah. So yeah, we can ask questions. So in this case, well, yeah, this model is hosted in Azure. It is still using a 5 model. So yeah, you can deploy them locally or maybe in the cloud, up to you, okay? And well, yeah, as I said, I think also I ran out of time. So I appreciate everyone for being here in this talk. I will just go through the chat. If there is any other question, please let me know. Thank you very much for the space, and I hope that this presentation was useful for you. So happy to connect, and of course I can also share this on GitHub. So yeah, I will provide or update my GitHub with that.
Thank you so much, Luis. Amazing presentation, very deep technical level, and I think you have quite an audience, my friend. I
Yeah,
can
yeah,
see the
yeah.
comments.
I
Uh,
shared some yeah, I shared the event with a few colleagues from Latin America, so I'm happy that they are here. So I appreciate it. Thank you, thank you for joining.
Great. We have a question, if you don't mind.
Yeah, of course, no problem. Yes. So yeah, so the hybrid scenario with Olama hosted in Azure, find the local network and your own database. Yeah, as I was mentioning, so you can evaluate the speed, the latency that you get. If it is acceptable, you can go for example, for local infrastructure uh, to reduce, for example, the cost. There is no difference. Like if you use some model, the same model in the cloud or locally, the results should be similar, should be the same. But yeah, you can you can go for both or locally. Yeah, I have used this locally, and yeah, it works. So yeah, we can follow on that question if you want, Jorge, later on Discord. And arriba el América. Okay. Yes, and also Antonio Jesus from Spain as well. Yes, also greetings to Spain, because some people from Spain are also much. Chido presentation. Thanks. No problem, Jorge. So yeah, thank you everyone, and I hope that you stay for the next session. It is also going to be interesting, so you can learn about semantic kernel. So I'm going to stay here as well. So thank you again, and I hope that you enjoy the rest of the event. See you next time.
Thank you, Luis. It's a wonderful session. Thanks for your time. And we have a next session. Thank you.
Bye bye. See you. Bye bye.
Bye. See. Okay. Hello, everyone. Thank you all for joining the session at Azure AI Connect 2025. It's been an incredible 5 days of learning and collaboration. This is our final session in room 2. We are excited to have Alan Fleiss with us. He is a Microsoft Regional Director and Azure AI Platform and IoT MVP. He has 30 years of experience. He is a leader of Israel Azure developer community. He is a respected speaker and mentor. Today, Alan will be speaking on Semantic Kernel, redefining C# development with AI-driven solution. Let's welcome Alan Fleiss to the stage. Alan, the stage is yours. Let
Thank
me
you.
share yours. Yes,
Yeah.
let me share your screen. Okay, stage is yours.
Yeah. So thank you very much. And I'm the lucky one to close the conference. So thank you for all of you that stay for the last lecture. Actually, I watched the lecture before, and he already talked about semantic kernel. So I hope that I will even go deeper and give you more information and knowledge about semantic kernel and the new features of semantic kernel, like the agent framework. So my name is Alon Fleiss, and I'm the CTO of a software house named Zarnet. I also the author of the Architecting Scalable Solution book. I'm now in the middle of writing the book. It's now 350 pages. And I created a coupon for you. So if you're interested in reading about software architecture and also assist me in shaping the book, please do read the book and provide feedback. So let's start talk about AI and semantic kernel and how it changes the way that we design architecture, design, and write code. It's like a total disruptive new era that we all need to adjust and adapt because we are going to change the way that we develop. It's not just the tool that assist us to develop the code, it's also the libraries and the technologies and using LLM or SLM or small language model, as you've heard, inside the code. And you should know how, when, what we should do using the old way of doing code and what we should do using large language model. I will try to follow the questions. If you have, it's on my right side. As you can see, I look to the side. Um, and feel free to ask question. And if I will not address the question now, I will address them at the end. But I will try to see if there are new questions anytime. So we are going to talk about AI and large language models. We are going to talk about, as we said, the way that they change the way that we write code. About this hybrid approach of doing things using LLM and using imperative code. And then, of course, we are going to talk about semantic kernel. You heard a little bit about semantic kernel. We will go deeper and we see various scenarios. So we'll start with a little bit with theoretical part, but then we will go and show me the code. We will look at examples and code. So comparing to all other revolutions, technological revolutions, the AI revolution is like the fastest one. It's like it took 3 months to reach to 100 million users. It's amazing the pace that this technology changes everything. And they say that the AI is going to replace developers. I say this is actually the opposite, at least for the coming years, because every app will be reinvented, every app will be changed. AI is the new UI, AI is the new brain, AI provide new capabilities, AI changes the way that we write code. So all our old applications probably will change because of AI, which means we need more people. Of course, it's gonna be, and it's right now easier to develop using AI, but we need to develop many more applications. And AI, you need somebody to tell AI what to do, and you need to understand how to tell AI what to do, and you need to be guide the AI and check the AI and validate the AI. So it's not just we will tell AI, build an application for me and that's it. And this is why we are going to work even harder. So if we are talking about Azure AI, there are different foundations when we are using Azure. And of course, Azure is not the only source for AI. All the major cloud providers will give you the foundation for AI and also Hugging Face and other. But if we are focusing on Azure in this conference, we have the AI services, which is like any other managed service. I need to do something. There is AI that knows how to do it. I just call it. And actually, before LLM, it was the way to do managed services. Now the limits are, a little bit. You can go and take some ready AI managed service like image recognition, or you can use a vision model that will do the same. So again, there are specific AI services that you still want to use, but there are also models that replaces these AI services. Of course, there is the machine learning, all the machine learning stack when you need to train your own model. If you want to do some, I nowadays call it the classical machine learning, the data science part of machine learning. And of course, there is the new UI tools, and you saw the Azure AI Foundry that take all of it and provide you a one place that you can consume, deploy, play with all the AI options. And again, we will look at it quite soon. So when I said that AI is disruptive and we need to change the way that we develop, there are two models that we need to look at. The old model is the deterministic code. We develop our code, we write a specific deterministic code, and then we can have a QA, whether manual or test automation, and we can check exactly the output that we think this code should return, and it should be deterministic. When we go with AI, we can no longer base the result or check the result for an exact outcome. We can check or evaluate the output or the outcome. I mean, we ask something or we do something, and we can check, is it good enough? Does it provide what we are looking for? But there is no deterministic way to say this is supposed to be the actual output. Sometimes when I do unit test or integration test against AI, I would say, you know what, this text or this word or this subject should be in the output because I asked to do something and it must have this kind of result. But I cannot be completely sure that this will be the result. Actually, one way is to check or evaluate the result of or to create test is to use AI to test AI and to use AI to evaluate AI. But the way of development, the way of thinking is different. If in the past we said it was a computer mistake, it was a bug, now the mistake is because of AI. This was the result. I don't know why the AI decided to tell me that this is the result, but actually we get something that we didn't think about it, or it wasn't in our code. It was the result of querying an AI. And it's a challenge. But it also provides new capabilities. Think about volatility in code. And in my book about architecture, I talk a lot about volatility. Volatility is the thing that probably will change. When you design or when you do an architecture to your system, you need to think about what will be stay the same and what is going to change. And for these things that are going to change, I need to create something in my solution that will be flexible. For example, I can use business rule engine, I can use script, I can use workflow, I can use something that my user will be able to change the code without the need to rebuild it, change the code, recompile, rebuild, deploy, and everything about the code. This is volatility. And we think about agent or AI agent, it's very easy to change the way it works. Just change the prompt and it will behave differently. Sometimes the volatility comes because you do something, for example, you just change the model and the behavior is different. So AI is great when you need flexibility, but you also need to evaluate it because you change the model and now the results are totally different from what you thought that they should be. So comparing using LLM, using AI to business rule engine or workflow or script, it's much easier to change prompt than to even adding this kind of capabilities to our code. But again, we will lose some deterministics. So the way to build application is to think about what we gain from each side of these different ways, different brains. We can use our code to do the deterministic stuff, to do something which usually very efficient. We know what is the result. For example, think about mathematics, all the calculation. AI is not so well with math, but AI can drive regular code to do the actual math. It's like we use calculator, we know what to type to the calculator and what to get the result, but the calculator will be much faster and can calculate much more complex expression than we are, okay? So when you write code, you need to think this is better to do with regular code and this is better to do with prompt. And there are lots of different mix and match that you can do between the two sides, okay? So, in few minutes, I'm going to show you how we can leverage these dual possibilities and how we can call from code to AI. Actually, you saw it in the guys that were in the last lecture. You saw how to call semantic kernel function but I will show you how to call and to call back and how to do mix and match between the different options. So this means that we need to get into semantic kernel. And semantic kernel is just one solution to bridge between the world of regular code and LLM. Actually, if you look at the Azure AI Foundry, you will see that there is also AI Foundry SDK, and you can use the AI Foundry SDK to use LLM in your code. And you can use, if you use Python, you can use LangChain, and there are many other frameworks that you can use Olama locally without semantic kernel. So there are different ways to do it, but semantic kernels is one of the framework that I think is one of the most advanced that always change and update and find new ways to do stuff. And but the main idea is that we connect the core capability of C# and semantic kernel. We use our old way of code, and actually we can take code that we already have. We can take functions and classes and everything that we already have and combine them with AI. For example, let the AI call our functions. We need to be very careful because we need to understand about the outcome. What are those functions do, and is it okay to let the AI to call them? Is it just to get information, or do I have a function that will format my disk and now the AI can format my disk? So we need to be very careful when we give the power to the AI to call these functions, but we can. We can also use our code to dynamically generate prompt. Actually, if you think about all the chatbot, the prompt comes from the user. It's dynamically generated. Actually, the user thinks that the prompt comes from the user, but what happened is that we enter the prompt to ChatGPT, and then they take the prompt and they add so many rules and extra information and everything about the user, and then they push it to the LLM engine. So it's dynamically generation of prompt. But what we can do, even a loop, we can generate a prompt, ask the LLM to provide a result, check the result, and regenerate new prompt to get even better result. And if you think about the agent model, it's something like this, because agents are multiple LLM functions or LLM agent that needs to fulfill a mission, and there is an iteration, meaning there is a prompt that is changed until we get the result. So this is, you can look at it as a dynamic prompt generation. Of course, AI can call our functions, and the nice thing now is that we could use, I mean, when I started to use AI, there was no way for AI to directly call a function, so I did it myself. I called the AI, I provide list of functions, I ask which function to call, I ask what are the parameters that I should provide to the function, I get it back. I use C# reflection or dynamic to choose the function and to call the right function. I got the result, I put the result back to the AI. So I did what now we get for free from Semantic Kernel or even from the model itself. Semantic Kernel, when it just went out, there was a planner which knew how to call functions. And when OpenAI and now also other models provides the way to call functions, Semantic Kernel just delegates this responsibility to the model itself. So function calling is very important because it's not just we call the AI or the LLM, is now the AI and LLM calls our function, get the result, do something, it does something with the result, and then get the result back, or even call other functions. And of course, when the AI calls our function, we provide deterministic information. I mean, our function can calculate, our function can go and query something from a database and provide this information. Our function can filter things, ensure that that they are correct, so we get better deterministicism. Also, one of the features that we can do today with Semantic Kernel, we can use code interpreter, meaning we can ask semantic kernel to ask the model to create code for us, and then we can execute the code. So now it's not just that we can use code to create dynamically prompt. We can use the result of AI. We can use a prompt that creates code that we can run code. So it's like we close the loop. We can be very flexible in our code to create a prompt, and the LLM can be very flexible and create code that we can execute. And again, from the security point of view, we will want to execute the code in a sandbox and make sure that this code cannot do harmful stuff to our system. But again, this is something that we can do. And why we should do it? Because the AI can create code and that can do things that the AI itself cannot do, such as calculation or a flow. And this actually provides the maximum volatility when you think about it. So let's get a little bit into semantic kernel. And there is no question so far, I see, so we can continue. So semantic kernel, as we said, is a library. There are three languages. There is the Python, .NET, and Java. Python and .NET have many more functionalities compared to Java, but Java, you can also use Java with semantic kernel. It's open source library. There is documentation. I can show you the documentation. Actually, I think that if you're going to use semantic kernel, just read it. It's a very easy documentation. There is everything here. You can see that you can do C#, Python, and Java. See different examples. There are all the different concepts. I will talk about lots of them, but still you can go and read and play with semantic kernel. So lots of resources of how to get started. The idea and the reason they call it kernel is that the kernel is like the glue that combine or connect everything. We have our code. We have different plugins that provide functionality, also provide functions. We can define hook and filters. For example, when I ask something, when I have a prompt, so before the prompt gets to the model, we can have a hook, we can filter. And when we have result, or when the semantic kernel pick function, and on different cases like this, we can have hooks. So our code can get called and we can decide to stop execution or to change a bit the execution. So this is hook and filters. Semantic kernel also abstract the different models. So we write once and then we can plug in different AI models, small language model, large language model, different models coming from different vendors. Of course, it depends what are the model capabilities. If you need to ask questions about vision, you must have a model that supports vision. If you wanted to call a function, you must have a model that knows how to call a function. So it's not totally abstracted, but it's pretty good abstraction. Also, the code that creates the model is different between models. And I have on my GitHub a project named Semantic Kernel Pooling that also abstract the creation of the model from configuration. So you can look at my GitHub. So once we have the kernel, we have the prompt, we create plugins, we add them to the kernel, and then we can use the kernel to do AI stuff, for example, chat completion. We can use synchronous or asynchronous model, meaning we can ask and wait to result, or we can ask and get each token back and write each token, giving this user experience that we talk with somebody. And again, I will show you it in code. Some concept that will help you get started with semantic kernel. So a kernel is a glue. It's a very lightweight object. It's a class, but it's also an object. There is no interface. There is no ikernel. There is just kernel, but you can inject it in dependency injection. You can create multiple kernel. Actually, you can clone kernel and change it. And this is something that sometimes we do with agent. We create one kernel. We add the plugin that we want to provide to all agents. And then for each agent, we clone the kernel and change it a bit to be specific for this specific agent. And you can also destroy the kernel and create new kernel because it's a very lightweight object. But the main idea of a kernel is just it's the connection between the different AI parts or services. Then we have different AI services like chat completion, text generation, embedding generation for vector search, all the text to image, image to text to audio, audio to text, and even real-time WebRTC. Now, some of these features are still under preview. Some of them are already released. Then we have plugins. We have a predefined plugin, so we don't need to create all the plugins, but it's very easy, as you saw if you were in the last lecture. It is very easy to create plugins from your code or from your prompt. Then we have functions. We have two types of functions. There are native functions, which are C# functions that we decorate with some attribute and tell Semantic Kernel these functions belong to this plugin, and you can call it. And we have prompt functions, which are the prompt functions are based on template, a prompt template. So we don't need to write code, we just write prompt. And again, we can combine different kind of plugins and function in the kernel for our solution. There is also a vector store, and here originally they call it memory. And if you look at code related to vector search, vector store, and memory, note that there is a new way to do stuff. So if the code is like few months old, is the old way. And if you ask any LLM to give you an example, probably it will give you the wrong example because they just change it. So first what you should do is send the LLM to learn about the new stuff about memory and then ask the questions. So the vector store, the idea is that we can do embedding and vectorization, store information in VectorDB, and tell Semantic Kernel, whenever we ask you this kind of question, also go and take it from memory, meaning do a RAG. Then we have text search, which is a wrapper on top of vector store to do the search. But we can do also web search, meaning there is predefined plugin for Google search and Bing search. So you can just use, and I will show you soon how to use the search plugin for your solution. Also, there are new frameworks, two frameworks. One is the agent framework that I will present, and this is how to create multiple agents. Each one of them is expert in specific area, and we can combine them to create a chat between agent and create chain of thought that solve the problem or answer the query. And there is a processor framework. This is very new framework. It's in the very beginning. And the idea of the processor framework is to do some business flow logic. Think about workflow or Saga or this kind of stuff, but using AI. So these are the key principles, and I think it's now time to show the code. So again, I don't see any questions, so I am continue. First of all, you can look at the code on GitHub. So everything is here, so you can go and play with the code. It's a new code, new demo that I created specifically for this lecture, and you can also give a star. But let's go and see the code and the different scenarios. So first scenario, code calls AI and also provide context, meaning history. Instead of looking at slides, let's look at Visual Studio. Now you can use my model because I showed you. Please do not, and I will change the keys. So let's see. We want to see how we use a simple solution. So we have, you saw the configuration file. Actually, just in demos, I use this way of configuration. I use Azure Key Vault or better ways to like a login to get the credentials, but for demo, it's much easier to get it from configuration, and then you see what happened. And then you have the problem that you forget to git ignore it, and it's also in your Git project, or it's in your presentation. So we take the model, we take the endpoint, we take the API key. These are all coming from configuration. We have a system prompt. We create a kernel, and we add the service of AI chat completion with all the parameters that we need. We can add the logging if we like to see what the kernel does, and also set the logging level. We build the kernel, then we take, and usually this can be injected to other, this is a very simple program CS, but it can be injected to your other services. So we ask for iChat completion service. We create a chat history that contains the complete history of the chat. And then once we have it, here we have a simulation of a conversation. So we add the user message to the chat history, and some color changes. We add we add the user message, and here we simulate the call. So we simulate the conversion of how long is the flight from London to New York City and to Seattle. So we see there is history, there is a context here. So if I will just run this code, where is the debug start new instance? We should see two answers with colors. How long is the flight from London to New York City? You see the log also, but you see the flight from London to New York City takes around 7 to 8 hours, and so on. And to Seattle, the flight from London to Seattle, so you see the context. So this is a very simple way. Just have a chat completion, call LLM, get result. Here we didn't do any call to any function, we just have history. Let's go on and move to the next. Okay. Next thing, we want to use just prompt function. So let's go and see prompt function. Layover with prompt, program. So here we have a folder with a prompt, the system, what they need to do, input parameters, origin and destination, and these are the list of airlines, including two very strange airlines, okay? And to call this prompt, we do this. The start is the same, okay, the same thing, but here we have the path to the prompt directory, and we add a plugin from the prompt directory. So whatever function you will put there in the directory, it will be part of the thing that the model can call. And now we have chat history. Since we have a plugin, now when we will ask the question, it will take the result, which airlines, from the prompt and not from its predefined knowledge, because it will see that we ask question about airlines. It knows that it has a prompt, so it will call this prompt function, and we will get back after all the login. We should get back. I didn't. Sorry. Didn't write didn't run the correct one. Debug, starting instance. I can drink meanwhile. So which airline has flight from London to New York City? And the result is actually what is in prompt, including London, New York City airline, which is taking the two inputs and provide the output. So very easy to create prompt function, very easy to pass parameter and to get result, and just add it as plugin to the model. So we finish this scenario of using prompt function. Of course, you can combine the regular function with prompt function. Now let's see how we can have a code that calls AI that calls code. And I think that if you were in the last session, you already saw that we can create a plugin class, give a kernel function, a description, and don't create too big description. After all, you pay for tokens. So if the class name, the function names, they are good, also parameter names, you don't need to give too much information. So think about the names. It's important because the AI gets the prompt about the plugin and the functions from doing reflection on your code. And here we do the same, but now in code, we return even these two strange airlines. So we can now run this code of calling, of doing, let's see, it's, which one is this? Function call, layout prompt. Is this the one? No, this the one. Okay, so here we have the plugin. Actually, there is a breakpoint here, so we can see that it calls this function. And this is the program. Again, we just add the plugin, in this case, from a type. So let's call it. And actually, we should stop on a breakpoint. So we stop, and you can see that from city is London to city is Seattle. This was the question, and now LLM gets the result and it shows the result. Easy. This is what's nice about Semantic Kernel. It's quite easy to use. Now let's talk about RAG, Retrieval Augmented Generation. Here we want to provide information from memory. Okay, so let's say in our memory we have this information about airline routes and other, and we want our code to retrieve the information from this memory. Why? Because sometimes we have too much information that we cannot just store, or sometimes it is very hard to do the regular query. And doing vector search, it means that we are looking for similar result. We are doing embedding, meaning create vectors from our entries in the database. And then we take the question, we create a vector from the question, and then we are looking for which vector from in the database is close to the vector of the question. And then we feed this information to the semantic kernel, and semantic kernel can choose from this information what to answer. Now, using semantic kernel function usually provides better result because we are pinpointing to specific data, but sometimes we need to use RAG. So let's see how we can use RAG. So it is this function. So we have a flight data, we have a function, and semantic kernel provides us a way to decorate our type. It's like a code first way, so we can decorate everything for the RAG. We also provide the embedding, the vector, and you should think, you provide the dimension. In this case, to make it simple, I use just a file, so I will read everything from the file into memory. Semantic Kernel provides a way to plug in any kind of database that supports vector, but in this demo, I prefer to use in-memory database, so I will not need to install or use a container. So I just create in-memory DB. So if you can see that I have in-memory vector store, and I have an embedding service. So I needed to add also model ID, an embedding model ID. And so I have the vector store, which is in memory, but it could be any vector store. And I create a collection for the vector store. and I create a wrapper, which is the vector store text search for Semantic Kernel, and this is actually the plugin. The plugin comes from this text search. So this is how Semantic Kernel can reach the memory. And here I simulate different questions against Semantic Kernel and memory. I also provide the parameter for the models. And to load the flight data, I just read the file, the JSON from the file, and I just push it to the memory. So I go on all the entries, and I just generate embedding to the entry, just insert it to the in-memory. And then I can simulate, I can just ask question, and the result of the question, oh, sorry, I again execute not the correct one, so sorry. So I can just see that now result will come from memory. So I have different simulation questions here, and result will come. So here we add to the memory everything from the file, and which airline fly from London to New York City. This comes from memory. You see that there is also this London New York City airline, and there is also other questions. So everything, all the knowledge comes from the memory, and you can play with it, change the data, see the different results. So this is how to add memory. Now the bigger, most complex demo that I will show, and it's about agents. How I can use Semantic Kernel to create an agentic solution. And the idea of using agent is that if you think about a problem, and for this example I took, I want to travel. I need to have a flight. I need to have an hotel or any accommodation. I want to have good restaurant. I want to see a show. I want to do something, some attractions. So I need different agents. Each one of them can be expert in his field, meaning that we can connect each agent to a specific source of information. And we can have different or provide different prompt for the agent so it will know what it should do. For this simple example, what I did, I provide different prompt, but I use Bing search, Bing plugin for all the agent. I also added a RAG for keep things that the user asks. So if I ask to eat in Italian restaurant, it will keep it. So next time when I will ask to eat in a restaurant, it will know that I like Italian food. So this is also in the example. So I use RAG, I use plugins, I use agents. And then you get what we call chain of thought. To make it even nicer, I created it with a web application so we can see the result. But again, this is a very, very simple system that uses agents. So let's see some stuff about it. So we have different, I created an interface called iSearch agent. So all the different agents can implement this interface. And all of them has the chat completion agents that comes from Semantic Kernel. And if we go to each of the agents, for example, accommodation search agent, you see that it implements the interface. We have the chat completion agent with the name, the instructions for the agent, like search for hotels and so on, provide this information, example, LLM really likes examples, so give it an example. Also, what is the agent name, and even when to call the agent. This is something that I added, so it will know which agent to call according to each query. The same as this agent, I create flight search agent and so on. I also create a travel planner agent. It's like the agent that will look after everything, understand the question, and if there will be no other agent to call, we will call this agent because it knows about everything, and it will recommend what we should do next to fulfill the request of the user. Also have the user preferences, which is the memory that's stored, and it's stored in a file. So you can see that there should be something that it learned from what I ask, all the questions that I ask. So this is the file, the same as we saw in memory before. And we have the chat service. So before maybe the chat service, let's see how it all starts. So this is the extension function that add all the requires models and agents. So we take everything from configuration, we create a kernel, we add the embedding so we can do the RAG. We have the OpenAI chat completion. We have a Bing search plugin. So all the agent will be able to search using Bing. For that, I also needed to have a Bing API key. And I create the collection of search agent. And then I call the chat service, path everything to the chat service. And the chat service, it keeps everything, and when we call initialize, it gets the text embedding for the memory, and the search plugin, and this is the most important part. We create an agent group chat. So this group chat will have a list of agents, and they will be able to communicate one with each other. We need to provide two functions. It's like a kernel functions, but one of them is for the selection strategy that needs to select the next agent. And another one is the termination that checks whether the chat complete and we have the result. So for the kernel function, there is this selection function that needs to return back which agent to call next. This is the result of the selection function. The termination function needs to say we finish. So something like return yes or no, whether we finish or no, and then we can check if the answer return yes, if the termination return yes, we finish with the call. We can also truncate the chat history. We have different truncation reducer functions. There is a summary one that summarizes the history, or there is truncation that forget history. So for this example, I use this one. It's simpler. So this is actually how you do it. You just create the chat group. Then when you have a conversation, you get the user message. I also provide cancellation, so user can stop the chat. I create the chat message from the user. I add it to the chat group, and then I read asynchronously every token of the result. That's it. I use for the UI, I have here this page that just presents the chat area, and here I do the call to the conversation. That's it. Let's run it. Okay, it's opening another window, so let me move the other windows to here. And let's ask question about something related to flight. Plan a 4 days in New York with a flight from this, and provides an hotel, what to eat, what to do. I will fly on the 18th of March 2025. Send. So the first agent that will start is the travel agent that will need to take what I ask and decide what are the things that we need to do. Once it creates the function that choose the next agent, it first choose flight. So now it calls the flight agent. Actually, I have here the logs so we can see everything that happened, but you can see the chain of thought. So flights, accommodation, activities, dining, it still thinks there are still iteration. Usually we will not see all of these we will not show all of these to the user. Sometimes we will let the user see what are the things that happened. And you can see that we start to get things that we can do, eat, stay, and so on. Now, we just use Bing, so it's not like going to specific sources for specific flights, specific restaurants, but even just using Bing, you can see that the result is very, very impressive. Okay, departure, routes, look for flights. So it sent me to do Google Flights, even though I asked for specific flights. But if I would connect to a GDS, which is flight information provider, I would get specific flights and with specific prices. And this is why it's continued to run, because the termination function is not satisfied yet, because we didn't get everything that we wanted. But you see the idea of how we can use different agents to fulfill different needs until we get back to the client and return the answer from the different agents. Okay, so let's sum up what we've seen. So we talked about the way that we need to think now about code and design and how we create new systems. We can leverage the power of AI and LLM to do flexible stuff. And we can leverage the power of regular code, the way that we used to write, to do the deterministic stuff. And we can combine the different approaches together. We can call from our code to the LLM and even create custom prompt for that. We can ask the LLM to call our code using plugins, and we saw different plugins like search plugin, like Bing Search, our native function plugin, prompt function plugin, and RAG plugins for memory. And we can even ask LLM, I didn't show you an example for that, but you can see in the documentation, we can even ask LLM to create code and execute the code to create even more flexibility. So we are just right on time. We have 1 minute left. So if you have any question, feel free to ask. If not, feel free to reach me, or even if yes, in my LinkedIn and also GitHub. Here are more links if you want to learn more. And again, you have discount to my book, and I really appreciate if you will provide feedback. You're muted.
Yeah, I'm sorry. Yeah, I'm muted. Thank you, Alan. It's a great session and it's really impressive demo. I don't see any questions, but I have a question. Do we have any key architectural patterns used in Semantic Kernel to handle AI-driven workflows? Is there any specific architectural patterns we need to follow?
I think it's new, right? So we are all learning how to use it correctly. Again, from my point of view, and as I said, usually when I analyze a system and provide architecture for the system, I always think about what is going to change, because this happens a lot, right? We create a solution, we try to create a solution domain, meaning that we can later change a bit the solution and answer new requirements. And AI and LLM is great for these capabilities. I mean, if you give the user the ability to change the system just by changing prompt, it's great. So what it means is that if we think about microservices as a way to break our code to small services, we may need even to break further. Because if we will have very small Lego blocks, now using LLM, we can build whatever we like from those Lego blocks. So I think that the main change is that think about the different capabilities and responsibilities that your code provide. Give away a responsible way for your LLM to call these capabilities, and then using even prompt, you create whatever you like. And I think this is the change that we need to look at.
Yeah, it's really good actually. Thanks for explaining the code, and it was really wonderful. I enjoyed I'm a C# developer. I really enjoyed it and explaining every function. It's really mean. Yeah, thank you so
Thank,
much. Thanks
thank
for
you
your
very much.
time. Yeah.
And bye.
Okay. Yeah. Thanks.
Bye.
Bye.
Bye. Bye.
Bye. Bye. Okay, that brings us the end of the season. Okay, Costas, you're here. So you're going to give the end note? You're on mute.
Yes, thank you, Suyabu. Thank you for being here. I'm just going to say goodbye. A big thank you to you and the team of moderators that supported the event. Big thanks to our attendees. Remember, you can connect to ai-athens.gr and see every session that was delivered by our amazing speakers. Hopefully, this event will continue to live on, and next year we will have more exciting sessions. Big thanks to Azure Developer Community Tamil Nadu. Uh, Goodbye, good day, good evening, and good night to everyone. Bye
Thank
bye.
you. It's pleasure. Thank you so much.
Bye bye.
Bye.